Morning. Good morning. We're ready to start. All of you made the long and dangerous trek from the 4-H Center. Congratulations on that. My name is Bill Valdez. I'm the Director of Workforce Development at the Office of Science, Department of Energy, and it's my great pleasure to be the head of the office that actually sponsors this event. And this is the 20th year that our office has been holding the National Science Bowl. It started from very humble beginnings, but has now morphed into this amazing event that crosses the country and includes now the middle school in addition to the high school Science Bowl. I'm going to be introducing David Zarin in just a moment, but first I wanted to tell you about a couple of important things. The first is that this is the 20th anniversary, and there have been a few people who have been associated with the Science Bowl from the beginning, and one of them in particular has been the heart and soul of the Science Bowl. Many of you know her, but I'd like to take this moment to personally thank Sue Ellen Walbridge for her 20 years of service, to you, the students of America, to the nation, which she has served both in the capacity as a civil servant in the Department of Energy, but also as a member of the Senate staff for 11 years. Sue Ellen's career is amazing. She's a person who believes that the public good, serving the public and promoting education, is one of the top priorities of our nation. She lives it, she embodies it, and Sue Ellen, thank you so much. Oh, come on, do it again. Yeah! Now, a few months ago, I wrote a nomination for Sue Ellen to the Service for America Awards, and those are called the Sammys, and they are the most prestigious award a civil servant can win. And I nominated her in the Lifetime Achievement Award, and she was selected as a finalist, and on Wednesday she will be honored for this, and I think it's a wonderful capstone, to a career. When I wrote the award, I said that when she wins it, she is going to turn beet red, because Sue Ellen really is a modest person, and she's somebody who really does not like to be in the limelight, does not like to be taking credit for the many things that she does. But I think this is an opportunity for all of you during the rest of this day to go up to her and personally thank her for her service. And again, thank you, Sue Ellen. And by the way, she did turn beet red, So now it's my great pleasure to introduce David Zarin, who really needs no introduction. He's been doing the Master of Ceremonies for the National Science Bowl for at least 10 years. He is the voice of the National Science Bowl finals. David, would you like to come on up? You can find his bio in the book. I'll let you read it, he is with the Prince George's Public Schools. He's an educator, a scientist, and somebody who understands the meaning of the National Science Bowl in a very, very real way. David?
Thank you, Bill, for that wonderful introduction, and thank you especially for your kindness to our great friend Sue Ellen, who is just the world's best. Sue Ellen, my hat off to you. What Bill didn't tell you is, among the other things I do, I'm a professional game show host. I do a show called It's Academic up in Baltimore and here in Washington. I'm also a television weatherman for here on the ABC affiliate, and I caught grief this morning because for the second year in a row I ruined it. I walked in and they said, "You couldn't have done better?" You know, this is the reason why diplomats in Washington used to get hazardous duty pay, because it is so warm and humid and muggy here. So my apologies about the weather. You know, I was in the Whole Foods yesterday after work, and this woman was struggling to reach some bread, and she said, "Young man, could you help me?" I liked her because she said, "Young man." And I said, "Sure." And she looked at me, she said, "You're somebody famous." And I said, "Well, I don't know about that." I said, I do the weather on Channel 7 here. She said, "No, that's not it." She said, "You're that man on The Amazing Race, aren't you?" No matter what I said, in her mind, I was Phil Keogh, so sometimes you just have to go along with it. You know, the reason I come back here every year is because I appreciate so much the passion that the Department of Energy has for this Science Bowl, and especially what Sue Ellen Walbridge does. Some of you might have noted in that big brochure that you had that we are being streamed live this morning. Potentially millions of people will be watching this final. And even though the demographic, even though we're not going to have as many viewers as, say, Dancing with the Stars or Are You Smarter Than a Fifth Grader, the demographic will be elite, because you're going to have colleges looking for talent. You're going to have companies tuning in to see who might we have as part of our team in the near future. We're going to have all of your parents and relatives, and we're going to have the President and First Lady of the United States. So that's not too shabby to have people like that watching what you do. If you'll permit me, I want to say a few things about my friend Sue Ellen, just as Bill did. It is certainly good to be back again as part of Sue Ellen's excellent adventure. This has been my 10th year doing this. This grand event has taken place for 20 years because one woman had a vision of what it could be: an opportunity to showcase America's scientific talent, to encourage scientific careers, and to acquaint young people with what government does and what a great service opportunity it provides. I hope you consider government service. Sue Ellen Walbridge has brought over 300,000 students into her scheme over these 20 years, and the proof of the game's reach is everywhere. I know you read the bios of the alumni who are visiting us today, and there are 20 of them here in the front row, and marveled at how accomplished they've become and how grateful they are to Science Bowl. For many participants at Science Bowl, this event is an epiphany. I quote for you Rena Joubert's note to Sue Ellen. Rena was a student last year at Westford Academy, and she said, "Miss Walbridge, I woke up on the first day back from Washington feeling refreshed and rejuvenated. Even though we studied harder than ever and slept even less than usual, as soon as it hit us that we were really at the National Science Bowl and that we weren't dreaming, the experience was somehow relaxing. We'd had so much fun and so many laughs. My love of science had returned. I regained my intellectual curiosity, and I once again had the motivation to learn not for a grade or a prize, but just for the sake of learning. I could tell that my friends on the team had been similarly affected." There is no question that Sue Ellen is totally into this game for one reason and one reason only, and that is you. Who else would agonize over an agenda that combines fun and majesty with the elements of High School Musical, the SAT, and high drama? It's Sue Ellen's boot camp, where you're told when to turn the lights out like you're a little kid, and the next day you're hustled off to meet and be extolled by the senator from your home state. Bill Valdez says that taxpayers get a great return on Sue Ellen, since she typically gives 200% to DOE. As a reward, Bill got her a new office, which, while much appreciated, probably doesn't see much of the ever-in-motion Sue Ellen. So impressed with her was First Lady Michelle Obama that she recently saluted Sue Ellen on a visit to DOE. The First Lady said, "I understand that Sue Ellen wants to retire, but put it off until she could make it in even 20 years with the Science Bowl." Look, I think we all know this is something pretty special. To start from something so small and grow it into something so big and meaningful, we are grateful to you for your dedication, your hard work, and your passion, and we are all so proud of you, end quote. Even the naturally shy, self-effacing Sue Ellen allowed that the First Lady's tribute was, and she said, way cool. You won't find, among all those bios in your book, a bio of Sue Ellen Walbridge, which is a grave omission. But you should know that she started in government as an aide to former Vermont Senator Bob Stafford and helped him pass legislation protecting the disabled, veterans, and minorities. Know, too, that her portfolio here at DOE includes far more than Science Bowl, extending to graduate fellowships and undergrad lab intern programs. You should also know that despite a lifetime of wheelchair confinement due to spina bifida, her fiercely independent can-do spirit takes her to Reagan Airport as a volunteer information guide, to her church to teach gospel classes, and remarkably to foster parenthood for children born with AIDS. Besides all that, her brownies and cookies are legendary, which makes a trip to her office around lunchtime often one with sweet ulterior motives. You know, if you Google Sue Ellen, you get hundreds of thousands of returns. The most are for Sue Ellen Ewing, the two-time wife of the nefarious J.R. Ewing on the TV show Dallas, which was probably before most of your times. Next in the list of Sue Ellens is Sue Ellen Mischke, the O.J. Henry candy heiress on the Seinfeld show who famously wore her bra outside her clothing. And next on the list is Sue Ellen Walbridge with 23,742 returns. Needless to say, the only real woman among those three, and the most authentic Sue Ellen any of us will ever meet, is the last of those three. Ladies and gentlemen, Sue Ellen Walbridge. Sue Ellen, you're wonderful. Can I ask how many of you are here for the very first time? First time to the National Science. Wow. Have you had a good time? Yes. Do you want to come back again? Yes. I loved reading about you. Those little bios, some of you are really creative writers. Where is Durant High School from Plant City, Florida? You guys rock. I love that picture. I didn't know curling was a big sport down in Florida. Craig Bearson, where is Craig? Is he among that group? There's Craig. Craig said, "This is the second year in a row I've been to National Science Bowl. I'm so excited to be back to receiving even more free food." That's one attitude. I like it. One of our alumni here, in fact, he was first here in 1991, Dean Jens, he's right in front of me here. He's going to be telling you about the game in a moment. But I noticed when he wrote his little bio, he said in 2008, he left to hike the Appalachian Trail and pursue graduate studies in economics. After what happened with the governor in South Carolina, you really did hike the trail, didn't you? All right. Where's Alyssa Young from Falmouth High School in Massachusetts? Is the Falmouth team here? I loved what you wrote, Alyssa. This was like a personal ad. She said she enjoys sunset walks on the beach and is currently single. Very nice. Very nice. And where's the team from Montgomery Blair in Silver Spring? There you guys are. I'm sorry about that. You know, they and Woodrow Wilson High School here in the district and Thomas Jefferson School out in Fairfax County. Where's Jacob Hurwitz? Jacob, nice to have you here this morning. Jacob said, "I'm so excited to be back and to win yet another all-expense-paid trip to the Maryland suburbs." Yeah. Some of you came from California and Hawaii and the Virgin Islands. He took the metro to get here. I'm sorry, Jacob. Some of you do things that are a little scary. A little scary. Where's Joseph Botros from Terre Haute South Vigo High School? There he is right in front. Joseph says he's a member of the Indiana-Oregon Procurement Agency. That's a little, I hope that's voluntary. That's voluntary? Yes? And Mohammed Shamin, who goes to the Science Academy of South Texas. Mohammed, are you here this morning? There he is. Mohammed says that he is currently designing an engineering solution to prevent surgical flash fires. Surgical flash, that's a problem? Fires in the OR, spontaneous combustion during your appendectomy. I don't know what that means, but it scared me. It scared me. There's a young man out there who I wanted to introduce you to. He is from, I think, the longest named high school here, West Windsor Plainsboro High School South, Canal Desai. Where's Canal Desai? Is he here? There he is right there. This is a great story. He has an extensive collection of miniature mugs from around the world, but they're so tiny that he hasn't been able to find them in years. You know, we have some real superstars among us this morning. From Lux Middle School in Nebraska, Ashke Rajagopal is where is he? There he is right over there. I saw you on television when ABC covered the National Geography Bee. He was the champion, and the Nebraska governor named a day for him. Nice to have you among us. And where is Evan Quarrelsome from Will James Middle School in Montana? Where is he? He's way in the back there. Congratulations, young man. He is an accomplished paleontologist. He has 2 species named after him, a kind of raptor and a hadrosaur. Some people wait all their lives for that. What do you have to look forward to? What do you have to look forward to? And the last little vignette I want to share with you comes from a coach. Where is Coach Paul Ricks from Hopkins Junior High in Fremont, California? There he is. Oh, you got a front row seat. Who did you know over there? Coach Ricks says he hopes that one of his former students wins a Nobel Prize and gives him founder's stock in his or her company so he can enjoy the kind of retirement he really deserves. I like that sentiment. I like that sentiment. All right, let's get started here. You're all sitting, you're waiting to find out who's going to be the champion. You're waiting for what awaits on the other side, a marvelous lunch. The First Lady is coming, Secretary Chu. It's going to be a wonderful morning. To get us started out, I want to introduce you to the president of the National Building Museum. This is where you're sitting right now. Right now. Here's a quiz. How many bricks are there in each one of these Corinthian columns? How many bricks? Nobody read the brochure. Where's Mr. Wren? There he is. I'm sorry, they're very poor students. They're very poor students. 70,000 bricks in each one of those. Some of you might have walked in and thought this was the American version of the Parthenon. It certainly looks like that. It's a magnificent building. Inaugural balls are held here. Some of Washington's most elite social events, including this one. And here to tell us about this, and you know, when I asked Mr. Wren if the Obamas had a ball here, he said, yes, there was the Commander-in-Chief ball. And he smiled very widely and said, and I got to go. Of course, if you've got the key and you're not going to open the door unless they invite you, that's what happens. Ladies and gentlemen, he hails from Seattle. We weathermen always say if we don't know anything else, it's raining in Seattle. Mr. Chase Wren. Please welcome him.
Good morning, and I'm sorry to disappoint, wrong president, but welcome. It's really my honor to welcome all of you here today to our little cabin here. And Sue Ellen, wherever you are, we are so thrilled to have you back. It's just terrific to see you once again. This is one of our favorite events. We're very proud to host this year's U.S. Department of Energy's 20th National Science Bowl and to be amongst the nation's brightest students. It seems very fitting that this year's competition is being held here. For 30 years, the National Building Museum has ignited the imaginations of students and introduced them to the fields of architecture, design, construction, engineering, and planning. Nowhere else in the world will you find a cultural institution addressing all aspects of the building arts and sciences. We're also very proud of our partnership with the U.S. Department of Energy. We've shared a long history of collaborating on projects together, and in fact, we currently have an exhibition on display featuring the 2011 U.S. Department of Energy's Solar Decathlon participants. This exhibition is a showcase of the team's models and will be open here through mid-July. In addition, the National Building Museum has chosen to recognize the U.S. Department of Energy's Solar Decathlon at our Honor Award Gala, saluting civic innovators on May 11th, next week. We're very excited about that. We're thrilled to be a part of the national event. I know each of you have worked extremely hard to get here, and I wish you all the best of luck. Now, I do want to tell you, just to follow up on the count of bricks, this building is made of 15.5 million bricks. I think one of the reasons why this building is still here is because if they tore it down, nobody knew what to do with 15.5 million bricks. So you just leave it here. We were fortunate enough to have the Obama Commander-in-Chief inaugural ball here. And you noticed in the center court, there's a giant fountain. And they covered that with a dance floor and had the presidential seal on that dance floor. And that's where the President and First Lady danced in this building. It was really a phenomenal moment. So we're very happy to be welcoming the First Lady back to the National Building Museum later this morning. Congratulations to all of you and have a wonderful morning. Thank you.
Thank you, Chase. What a great place to come to work every morning. You'd have to put you in a good mood. You know, Science Bowl would not take place without sponsors with deep pockets and deep commitments. And we're very fortunate to have 4 of our longtime sponsors with us today. Would like to acknowledge what they've done for us and we hope continue to do. First, from Bechtel, which generously contributes cash every year to support this. Would you please welcome Jake McLeod, Mike Kidder, Naomi Wong, and Jason Bond. If you're all here, thank you for 15 years of sponsorship of Bechtel. Thank you. Another of our longtime supporters is IBM, been with us for almost our entire 20-year history, and the special gifts that go to the winners of the Civility Award, which we'll be announcing very shortly, owe that award, the sponsorship, to IBM. Any IBM people here, thank you so much for all you've done for us. And all of our semi-finalists and finalists will be taking home calculators and computer-based laboratories courtesy of Texas Instruments. They have been with us also practically the entire 20-year journey, and we thank Texas Instruments. And our final sponsor, again with very deep pockets, and they're here all the time, the Areva Group, offering U.S. customers solutions for CO2 emissions-free energy generation. They employ 6,000 people in 20 states. If you see them, buttonhole them, network with them. They wouldn't be someone bad to work for. Alan Hansen and Nancy Lang are here. Thank you so much from the Areva Group. Thank you. We're so privileged every year. We have more and more alumni coming back to be part of our final competition. I hope some of you sitting out there in the competition will come back and join us again and share with us all of your successes and your expertise and be part of what we hope is a very, very long tradition. We have 20 alumni in attendance. Would they all stand now so we can recognize them and thank them? It's time to start our high school competition. Our judging panel, the people you have to be nice to when you come up here, I'll introduce them and they will tell you more about themselves and also go over some of the rules for those of you here who have not been privy to what goes on, just so you know what's going to happen this morning. First, our Chief Science Judge, Adam Matthews. Adam, right here in the front. Science Bowl alum from 1995 and 1997, and his beautiful young daughter, Abigail. I saw her earlier. Where is she sitting? Right over there. Abigail, future National Science Bowl contender. Our moderator, Dean Jens, right in front from the very first year, 1991 and 1993. So part of Science Bowl's aristocracy. Always nice to have you back, Dean. Our timekeeper, longtime DOE employee, Cindy Dalton. Cindy, right over here. And our scorekeeper, dedicated DOE employee, Nancy Marlin. Nancy, thank you for doing this, as always. And now I would like to have the first two teams report to the stage. I'll announce you. Would you please come up? The first team, they are undefeated, and this is their first ever appearance in Science Bowl's 20-year history, the North Carolina School for Math and Sciences in Durham. Would you please come up to the stage? Okay. North Carolina gets a bye in the first round, I've been told. Since they have perfect scoring thus far, they can sit back and watch the gladiatorial games here begin. So our first two teams then, both hail from California, both perennial contenders here. In fact, Mira Loma High School from Sacramento has been here 14 of 20 years. Mira Loma, would you please come up? And the other California team, I know they have won at least 2 Science Bowl championships, possibly more than that. The always wonderful team from North Hollywood High School. If you're planning ahead after the high school competitions, our plan right now is to take a break. The First Lady and the Secretary will be arriving, and then we will get into the middle school competition. But our first things first, our first high school double elimination round. And I'll turn this now over to Adam, who will do some explaining about the rules.
Thank you very much, David. I'll now let Dean Jens inform us about how the rules are going to be occurring today.
Okay, so this is the semifinal round. We'll give the teams a chance to get up here. Most of you know how this works. You have 4 points for a toss-up question and 10 points for a bonus question. We have 12-minute halves because we will have some visual bonus questions for which they will get 30 seconds. Non-visual bonus questions, they get 20 seconds. And one of these teams that is coming up to the stage right now will be competing for the national championship in just a few moments after this. I would like to remind the people in the audience, if you haven't already turned off cell phones and anything else that might make noise, to do so. I'll also ask that you remain in your seats for the duration of this time and not try to move around. There are a lot of people here and it's kind of crowded, and that wouldn't work very well.
Finally, can I please remind everyone, I know that you're all very excited to be here. I know that you all are very excited to play along during the finals here. But please, for the sake of the competition, so that we don't have any distractions for the competitors on stage here, please keep noise to an absolute minimum. No whispering, no talking to your friends, no saying what the answer is, nodding, shaking your head, anything of that nature, please. Let's keep it just for the participants on stage here. That's a very exciting moment for them. Thank you.
Okay. And as North Hollywood makes their way onto stage, I'll go ahead and introduce myself again. I guess I was briefly introduced that I was here the very first couple of years, and I've been here now 11 years as a volunteer. So I had the chance to meet Sue Ellen as a student, and then I had a chance to see more and more of what she does in the last 10 years. And I can tell all the students who think that she does an awful lot of work that she actually does about 10 times as much as you think. So we very much appreciate having had her. I'll go ahead and let the the other judges say something now. Go ahead.
Thank you. My name is Adam Matthews. As you heard, I am a Science Bowl alum. I was here in 1995 and 1997 from the Punahou School in Honolulu, Hawaii. I did my undergrad studies in biochemistry at Harvard College, a PhD in immunology at Harvard Medical School, and I'll be your science judge today.
Good morning. My name is Jenica Jacoby. I'm another one of the alumni volunteering here. Competed in 1998 from Albuquerque Academy. I'm going to be running your visual bonuses as a science judge today.
Mike.
Hi, I'm Cindy Dalton from IBM, and I'll be your timekeeper.
And I am Nancy Marlin from Department of Energy Headquarters, and I am your scorekeeper.
Okay, I would like to say hi now to the teams that have assembled on stage. Welcome, congratulations on making it this far. I would like you to buzz in. I will be recognizing you during the match. I would like you to, so we will do a buzzer check. I would like Team A, Participant 3, to buzz in, and when I recognize you, tell us your name and your year in school, and if you're graduating, tell us what you'll be doing in the fall. Team A3.
My name is Harry Levine, and I'm a junior.
Team A2.
My name is Kyle Lamb, and I'm a senior. I'll be going to Berkeley this fall.
Team A, Captain.
I'm Sean Mara. I'm a senior at North Hollywood High School, and I'm going to the University of Pennsylvania.
A1.
I'm Slater Victoroff. I'm a senior at North Hollywood, and I'll be teaching English around the world.
B1.
Sriram Pandela, and I'm a junior.
B Captain.
I'm Andrew Chen, and I'm a junior.
B2.
Edward Lee, senior, and I plan on attending Brown University in the fall.
B3.
Russ, I'm a junior.
Okay, so now you've each had about 2 seconds to use the mics. We will need you to speak into the mics, or near the mics at least, so that we can hear your answers. You'll probably get increasingly used to them as we go along. Also, certainly, let me know in some fashion if you can't hear me, I will try to I'll try to maintain my volume, and those folks over there will try to maintain my volume at a comfortable level that everyone can hear. Okay? Are we ready to begin?
Yes.
All right. Well, we'll begin double elimination round 7 with toss-up question number 1, which is in chemistry. Short answer. A reaction has a rate constant, K equals 25 molarity to the -2 power times minute to the -1 power. Give the overall order as an interrupt by B1.
2.
That is incorrect. I will repeat the question for Team A. Chemistry, short answer. A reaction has a rate constant, K equals 25 molarity to the -2 power times minute to the -1 power. Give the overall order for this reaction. A, Captain.
3.
3 is correct. Your bonus question is a visual bonus in chemistry, short answer. Answer the following 3 questions regarding the curve of KNO3. 1. Giving your answer as saturated, unsaturated, or supersaturated, describe the solution formed by completely dissolving 80 grams of KNO3 in 100 grams of water at 40 degrees C. 2. If a saturated solution of KNO3 at 60 degrees C was rapidly cooled to 30 degrees C, how many grams will precipitate out of solution per 100 grams of water? 3. What is the solubility in moles per liter to the nearest whole number of KNO3 at 40 degrees C?
Okay, 1 is supersaturated. One is supersaturated.
Got it.
5 seconds.
Supersaturated, 55 grams, and 65 moles per liter.
I'm sorry, the first 2 answers were correct, but the last one is 6. Toss-up question 2, biology, multiple choice. Which of the following is not true of microRNA molecules? W. occur naturally in plants? X, single-stranded. Y, about 19 to 25 as an interrupt by A captain.
Z.
Z, only produced by the genes that they regulate. That is correct. Your bonus question is a visual bonus in biology. Short answer. Answer the following two questions. 1. What is the most common scientific term for this general process? And 2. What is the most common biochemical term for the ends of the molecules shaded in turquoise where the orange and red colored balls labeled 3 are attached?
Five seconds.
Translation and peptidal site.
Translation was correct, but the other answer was 3' end. Toss-up question 3, physics, multiple choice. Which of the following characteristics of quantum systems has been most important to the development of quantum information systems, including quantum computation? W, complementarity. X, entanglement. Y, correspondence principle. Z, photon quanta. A3.
X.
X is correct. Another visual bonus question. This one, can we get that up? This one is in physics, short answer. This is a Feynman diagram of what form of radioactive decay?
Yeah, it's beta plus decay.
Beta plus decay.
That's correct. Toss-up question 4, general science, short answer. By words or number, name all of the following 4 choices that are typically used to reversibly denature proteins. 1, pH change. 2, alteration in amino acid sequence of protein sample. 3, mild heat for a short time. 4, moderate salt concentration as an interrupt by A captain.
1 and 3.
That is not correct. I will reread it for Team B because that was an interrupt. Toss-up question in general science, short answer. By words or number, name all of the following 4 choices that are typically used to reversibly denature proteins. 1, pH change. 2, alteration in amino acid sequence of protein sample. 3, mild heat for a short time. 4, moderate salt concentrations. B3.
1, 3, 4.
That is correct. Your bonus question is a visual bonus in general science, short answer. Answer the following 3 questions. 1, what is the common general name of this device? 2, which of the following 3 minimum operating temperatures is the most common setting for this device? 100 degrees C, 121 degrees C, or 167 degrees C? And 3, in the bottom right is a fill lever. What would this instrument typically be filled with for proper operation?
It's an autoclave, right?
Autoclave, 121 degrees Celsius, steam.
Can you stop the clock? No, we don't. That is not acceptable. The correct answer to the third one is water. It is not put in as steam.
We'd like to challenge that, please.
Okay.
Your challenge is?
The device is filled with steam, and steam is the gas phase of water.
We will discuss. Thank you very much. We've discussed, and the autoclave is filled with liquid water. During the course of operation, the water is converted to steam as the temperature rises, but it is filled with liquid water, not with steam. So the answer is incorrect.
So now we will move on with toss-up question number 5, which is an earth science multiple choice. Magnetic separation is possible in the case of which of the following ores? W, taconite. X. Cinnabar. Y. Cassiterite. Z. Molybdenite. A1.
Z.
That's not correct. B. Captain.
Y.
No, the correct answer was W. Taconite. Toss-up question 6. Astronomy. Multiple choice. If you were on a planet with an escape velocity of 1v and the mass of the planet remained the same, but its radius decreased to 1/4 of its original size, the escape velocity would be W, 1/2 v. That is an interrupt by A2.
W.
That is not correct. That was an interrupt, so I will reread for Team B. If you were on a planet with an escape velocity of 1v and the mass of the planet remained the same, but its radius decreased to 1/4 of its original size, the escape velocity would be W, 1/2 v, X, 1v, Y, 2v, Z, 4v. B. Captain.
2v.
2v is correct. Your bonus question is a visual bonus in astronomy. Short answer. This is an image taken in December 2006 by the Hubble Space Telescope. Answer the following 2 questions. 1. What celestial event produced the ring structure in the center of the field? 2. What particles were detected before the first visible light reached the Earth from this object?
Oh, really? Okay.
Supernova. Neutrinos.
That is correct. Toss-up question 7 is in math. Short answer. A baseball player hits a home run in 10% of his at-bats. What is the percent probability that in 2 at-bats he hits exactly 1 home run? A1.
0.09.
That's not correct. B3.
0.18.
No, that is not correct. The correct answer is 18. Stop the clock. The question asked, what is the percent probability? So you have to give it in percent form. The answer was 18%. You're on the right track. I'm sorry. So we'll go on to toss-up question 8. Chemistry, short answer. Give the systematic IUPAC name for tert-butyl alcohol whose chemical formula is left paren CH3 right paren 3 COH. B. Captain.
Trimethylmethanol.
I'm sorry, that's incorrect. A. Captain.
1,1-dimethylethanol.
No, the correct answer is 2-methyl-2-propanol. Toss-up question 9. Biology, multiple choice. The total amount of protein in human plasma is about 7 grams per deciliter. Which of the following is closest to the plasma levels of free thyroxine, adrenocorticotropic hormone, or estradiol in a human male? W, 3 picograms per milliliter. X, 3 micrograms per milliliter. Y, 3 milligrams per milliliter. Z, 30 grams per liter. A. Captain.
X.
That's not correct. B1.
W.
W is correct. You get a bonus question as another visual in biology short answer. This is an H&E stain of a human organ. Answer the following 3 questions. 1. Is this a longitudinal or cross-section? 2. What organ is this? 3. What specific type of tissue is labeled B?
So this is probably small intestine. I think it's no small intestine. This is the belt. Okay, it's small intestine. And then what's B? No, it's the circle. It's the muscle, right? B should be the muscle. A is not. I don't think it's smooth muscle. Smooth muscle. So the cross section, it's the small intestine, and over the smooth muscle.
5 seconds.
Cross section. Small intestine. Smooth muscle.
That is correct. Toss-up question 10 is in physics, multiple choice. The cosmological principle states that when averaged over very large scales, the universe is W. Homogeneous. That is an interrupt by A2.
W.
That is incorrect. I will reread for Team B. The cosmological principle states that when averaged over very large scales, the universe is W, homogeneous and homotropic. X, homogeneous and isotropic. Y, finite and anisotropic. Z, infinite, and anisotropic. B, Captain. X. X is correct. Your bonus question is in physics, short answer. Name all of the following four choices that, according to the Standard Model, obey Fermi-Dirac statistics. Protons, photons, mesons, electrons.
Protons and electrons.
That's correct. Toss-up question 11 is in general science, multiple choice. Which of the following is the statistical test of significance most appropriate for determining levels of significance in differences among four different alloys to conduct electricity under varying temperatures? W, student's t-test. X, standard error of the mean. Y, chi-square. Z, ANOVA f-test. A2.
Z.
Z is correct. Your bonus question is in general science, short answer. By words or number, name all of the following three choices that are true regarding the ANOVA f-test. 1. The null hypothesis is strongly rejected when the f value is highly negative. 2. The null hypothesis is least strongly rejected when the sample means are equal. 3. The test requires information about sample sizes.
Okay, 2 and 3 are true. I don't know that one.
It's strong if it's highly negative. If it's
The null hypothesis is rejected if f is negative.
Yeah, but makes sense. Yeah.
5 seconds.
all three.
No, it's just 2 and 3. And
That's a half.
We've gone through 11 questions at the half. We'll now take a brief 2-minute break and resume with the second half of play. Take your seats again. We're going to resume with the second half of play. Please take your seats.
8. Okay. You want to test the buzzers again? Okay. All the way? All of them? Oh, okay. All right. So there was an issue with buzzer for B2, so you would like to test it again. Go ahead. B2, it looks like it's working.
All right, sounds good.
You want to read the score at the half?
Okay. North Hollywood is 30 and Mira Loma is 58.
Okay, and we've done 11 questions so far, so we're going to start on question 12. I like to announce that so that the science judge can correct me before I start reading. Toss-up question 12, Earth Science Multiple Choice. Which of the following most likely erupted with the highest temperatures? W. The Lackey Fissure System flood basalt of 934 AD. X. Huckleberry Ridge Caldera at Yellowstone about 2 million years ago. Y. Mount Pinatubo in 1991. Z. A stratovolcano as an interrupt by B. Captain.
W.
That's not correct. That was an interrupt, so I will reread for Team A. Toss-up, Earth Science Multiple Choice. Which of the following most likely erupted with the highest temperatures? W. The Lackey Fissure System flood basalt of 934 AD. X. Huckleberry Ridge Caldera at Yellowstone about 2 million years ago. Y. Mount Pinatubo in 1991. Z. A stratovolcano from the Proterozoic eon producing ultramafic lava flows. A1.
Z.
Z is correct. Your bonus question is in Earth Science, multiple choice. Much evidence suggests that Earth's basaltic magmas result from which of the following processes? W. Dry partial melting of mantle. X. Dry partial melting of continental crust. Y. Wet melting of continental crust. Z. Wet melting of outer core.
None of them.
It's W.
Basalt.
Yeah, basaltic
I guess W.
5 seconds.
W.
W is correct. Toss-up 13, astronomy, short answer. Regarding Julian dating, how much time in hours to the second decimal place does 0.01 Julian days equal? B. Captain.
0.24.
That's correct. Your bonus question is a visual question in astronomy, short answer. Answer the following 3 questions. 1. The bright red area is aligned with the plane of what specific celestial object? 2. What general type of stellar remnant produces these pulsars? 3. What cataclysmic events produced these labeled objects?
Two is what?
Yeah, that makes sense.
Yeah, 2. Make sure to do jump. So 2. That's 2.
2 neutron stars.
And then 3. The cataclysmic events. So supernova.
Neutron stars.
Okay.
Milky Way. Neutron star. Supernova.
That's correct. Toss-up question 14, math, multiple choice. Which of the following is the minimum value of the function absolute value of x plus 1, close absolute value, plus the absolute value of x minus 1, close absolute value? W, 1, x, 2, y, 3 halves, z, 5 halves. A1.
Y.
That's incorrect. B. Captain.
Z.
No, the correct answer is X, 2. Toss-up question 15 is in chemistry, short answer. Which specific rule or principle, based on Zaitsev rule, states that the addition of a hydrohalic interrupt by B1?
Markovnikov's rule.
That's correct. Your bonus question is in chemistry, short answer. Giving your answer in degrees Celsius to the first decimal place, if the molality of a non-volatile, non-electrolyte is 0.3 molal and the solvent is acetic acid, what is the boiling point of this solution? Assume the boiling point of acetic acid is 118 degrees C and its abelioscopic constant is 3.0 degrees C per molal.
Okay, so that's 0.9. First decimal place of 100 and... 1 second. This is boiling point. 118.9 degrees Celsius. 118.9 degrees Celsius.
5 seconds.
118.9.
118.9 is correct. Your toss-up question 16 is in biology, multiple choice. Fungal hyphae typically have only small amounts of RER. From this, you would most likely expect that these hyphae would also have W, cells with no nuclear membranes, X, no free ribosomes, Y, small amounts of Golgi, Z, numerous peroxisome. That's an interrupt by B Captain.
Y.
Y is correct. Your bonus question is in biology, short answer. By words or number, name all of the following 4 choices that are generally true for regulatory mechanisms of cell cycle. 1. Cyclins are proteins that regulate the activity of CDKs. 2. Levels of cyclins steadily fall during interphase. 3. Cyclins steadily rise throughout mitosis. 4. Growth factors often act by stimulating cyclins.
I think one, no, because the reason, I don't think cyclin, they spike during the, and then they don't go, this is how they look like. And they decrease during mitosis. Yeah.
5 seconds.
1 and 4.
That's correct. Toss-up question 17, physics, short answer. What dimensionless fundamental constant is most often considered the coupling constant for electromagnetic force? B Captain.
The permittivity of free space.
That is incorrect. A3.
The permeability of free space.
No, the correct answer is the fine structure constant. Toss-up question 18, general science, short answer. By words or number, name all of the following 3 choices that are true regarding phonons. 1. They have no definite discrete properties or quanta. 2. They determine the speed of sound in different materials. 3. They play an essential role in superconductivity as an interrupt by A3.
2.
That is incorrect, so I will repeat for Team B. By words or number, name all of the following 3 choices that are true regarding phonons. 1. They have no definite discrete properties or quanta. 2. They determine the speed of sound in different materials. 3. They play an essential role in superconductivity. B1.
All of them.
That is not correct either. It is 2 and 3. Toss-up question 19, earth science, short answer. At a depth of about 2,900 kilometers below the Earth's surface is the Gutenberg discontinuity that lies immediately between what two as an interrupt by A Captain?
Mantle and outer core.
That is correct. Your bonus question is in earth science, multiple choice. According to the discontinuous branch of Bowen's reaction series, which of the following has the highest crystallization and is the first to form from a basaltic magma? W. Pyroxene. X. Amphibole. Y. Olivine. Z. Biotite.
Y.
Y is correct. Your toss-up question 20 is in astronomy, multiple choice. Most of the matter that astronomers would consider in the local area of the Milky Way galaxy is W, associated with the dark halos from the local group. X. In the far interstellar space among galaxies of both as an interrupt by B Captain.
W.
W is correct. Your bonus question is in astronomy, short answer. By words or number, name all of the following 3 choices of space missions that have provided substantial support of the hypothesis of the cosmological principle. WMAP, COBE, SOHO.
Yes, both 1 and 2.
5 seconds.
1 and 2.
That is correct. Toss-up 21 is in math, short answer. Simplify the following product. Square root of -9 times square root of -121. B Captain.
-3.
That is incorrect. A1.
-33.
That is correct. Your bonus...
Stop the clock,
Stop the
please.
clock.
We've used that question before.
I'm sorry?
We've used that question before in a round in double elimination.
It's true.
There was a question that was similar, but it was not
I
this.
think it was,
I actually think it was
exactly the
question.
same.
Regardless, it doesn't affect the answer. The square root of -9 times square root of -121 is -33, not -3.
It doesn't matter.
You should get.
It doesn't matter.
Thank you.
Okay, so visual bonus.
Continue.
All right, visual bonus for Team A in math. Short answer. In the given matrix equation, what are the values of A and B respectively?
Yeah. B equals
what? B equals 7.
Is it A negative 7 over 6? Are you sure?
What could be getting?
7 over 6. No, wait. 1.
5 seconds.
1.
A equals 1, B equals 7.
That's correct. Toss-up question 22 is in chemistry. Short answer. By words or number, name all of the following 4 properties that are usually decreased by the addition of a solute to a solvent. 1. Boiling point. 2. Freezing point. 3. Osmotic pressure as an interrupt by A captain.
The first and fourth.
That is incorrect, so I will reread for Team B. Short answer. By words or number, name all of the following 4 properties that are usually decreased by the addition of a solute to a solvent. 1. Boiling point. 2. Freezing point. 3. Osmotic pressure. 4. Vapor pressure. B1.
2 and 4.
2 and 4 is correct. Your bonus question is in chemistry. Short answer. Balance the following chemical equation reacting aqueous cobalt-3 nitrate with potassium sulfate using the smallest whole number coefficients. CO, left parent, NO3, right parent, 3, aqueous, plus K2SO4 aqueous yields CO2, left parent, SO4, right parent, 3, solid, plus KNO3 aqueous.
No, did you need to balance it? Remember the first story, please.
5 seconds.
2CO, open paren, NO3, close paren, 3, aqueous, plus 3, K2SO4 aqueous yields CO2, open paren, SO4, close paren, 3, solid, plus 6, KNO3 aqueous.
That's correct. Toss-up 23, biology, short answer. If the diencephalon was surgically removed during early embryogenesis, which one of the following 4 parts of the vertebrate brain would most likely be missing in the adult stage, assuming the animal could be kept alive? Thalamus, cerebellum, pons, medulla as an interrupt by B captain.
Thalamus.
That is correct. Your bonus question is a visual bonus in biology. Short answer. This table lists the 9 different routes of informational transfer possible under the central dogma of molecular biology. By words or number, name all that most scientists would agree are not known to exist.
Okay, protein to protein does not exist. Number 9. Protein to
DNA works. This works.
This works. This works.
This works. RNA dependent. This does not work. This does not work.
No, it's 3. It's 3. It's just 7, 8, 9?
Or is it? Has this ever been done before? Yes.
DNA to
So
protein.
it just,
Really? Okay.
what about prions? Are they protein? No.
Oh, no,
5
no, that is true.
seconds.
Prions are protein.
7, 8, 9.
That is correct.
And that's the game.
I would like to congratulate Miraloma on winning that match, and they will now play for the national championship. And I'm going to hand this over to Adam to moderate the next round.
I would now like to welcome North Carolina, our undefeated team, up to the stage for the National Science Bowl Finals. Round of applause, please.
Okay.
No, they're not.
They're listed that way as being. Because they had put in North Carolina. Oh, did they do it alphabetically? They probably did the first one alphabetically, but the other two they didn't know how.
The first one was backwards. North Hollywood. I think Maryland.
Yeah.
They flip-flopped it. Well, at least they're consistent.
No, this one they had the whole thing. They had the NC science and math. So I'm sure they just figured it out. Yeah.
Because I had already displayed it on us, then it's not. Then I advanced, then I
All right, thank you very much. This is now the National Science Bowl High School Finals. We have our two teams, Mira Loma on the B side, who you just saw in action, who won their last match. Congratulations, Mira Loma. Going up against North Carolina on the A side, coming out of the undefeated champions bracket. So congratulations to both teams, and this is the finals. One of these two teams will be our National Science Bowl 2010 high school champions. Have a round of applause for both teams before we get started. Okay, so once again, my name is Adam Matthews. I will now be the moderator for this round. I will be recognizing you during this round. And please wait for verbal recognition before giving your answer. Before we begin, we'd like to once again test the buzzers and have you introduce yourselves to us. We'll start at the left side, work our way across. Please buzz in, wait to be recognized, and then tell us your name, your year in school, and what profession you think you'd like to pursue after college and grad school. A3.
Bryce Taylor. I'm a junior and I'd like to be a mathematician.
Thank you very much. A2.
Christian Johnson. I'm a senior and I would like to do research.
A captain.
Akil Jarawala. I am a senior and I'm thinking about going into chemistry.
Excellent. A1. Sorry. Please buzz.
That's why we test.
Could you please check the buzzer for A1, please? And participants, we'll all be careful not to kick the wires on the table that will dislodge the connection and kill your buzzer. Thank you for your patience while we resolve this technical difficulty.
Not bad.
It's fine. If we could get some AV support on stage, please, to help reconnect the buzzer, please. Set. Thank you, Jisan. A1, let's try that again. A1.
My name is Patrick Yang. I'm a senior and I have no idea what I'm going to do.
Fair enough. B1.
Sriram, I'm a junior. I'm thinking of being a chemist. Not sure yet, though.
Excellent. B captain.
Andrew Chen. I'm a junior and undecided.
Thank you. B2.
Edward Lee, I'm a senior, and I would like to become a professional game show contestant, but medicine sounds okay too.
As a fallback plan, perhaps. B3.
Russ Islam, and either medicine or economics, or maybe medical economics.
Excellent. Thank you very much. So it seems like the buzzers are all working. You guys are all up here. Please do speak into the microphone during the round so that the audience can hear you and so that everyone watching around the world can hear you as well and be amazed by your brilliance. Do we have any questions before we get started? All right, well then without further ado, this is the finals of National Science Bowl High School Competition 2010. Take a deep breath, relax, and let's get started. Double elimination round number 8, toss-up number 1, physics multiple choice. Which of the following is most commonly taken to determine the geometry of the universe according to general relativity and the cosmological principle? W, age of the universe. X, temperature of the CMB. Y, rate of expansion of the universe. Z, average density of interrupt. A, captain.
Z.
Z is correct, average density of matter. Your bonus question is visual, in physics, short answer. There's a DC power source on the left of the diagram at I1. Given that the ammeters at I2 and I5 read 8 and 2 amperes respectively, what are the currents in amperes that are registered on I3, I4, and I6 respectively?
So I3 is 6 amps. I3 is 6 amps. And I think I4 is 4 amps. I6 is 12 amps. And then I4 is 4 amps. It's just I3, I4, and 6. What'd you get for
5 seconds.
I3 equals 6 amps, I4 equals 4 amps, I6 equals 12 amps.
That is correct. Toss-up question number 2 is in biology and it's multiple choice. Which of the following is a known mechanism that most often accounts for genomic imprinting? W, poly-A tails. X, DNA methylation. Interrupt. B, captain.
X
is correct. Your bonus question in biology is visual, short answer. Answer the following 3 questions regarding this medical x-ray. 1, what is the specific name of the bone labeled A? 2, what is the specific name of the bone labeled B? C, what is the specific name of the process labeled C?
That's the first vertebrate or the second vertebrate? See the atlas or the axis? Is that the axis then? So A would be the axis. So A is the axis. And is B the sternum? Is that far enough down? No, the sternum starts here. Sternum starts more.
Isn't it the weird thing?
No, I think it has to be sternum.
5 seconds.
Axis, sternum, acronomion.
I'm sorry, it's axis, first thoracic, and then acromion. Toss-up question number 3 is in chemistry, short answer. For a multi-step chemical reaction, which step determines the rate of interrupt B1?
Slow step.
That is correct. Your bonus question in chemistry is short answer. Name all of the following 5 species that have a tetrahedral shape. CH4, XF4, SO4 2-, SOF4, SF4.
It's on SF4, it's on SO4. It's SO4 2- does XEF4?
XCF4.
XCF4 does not, CH4 does.
So 1 and 3?
1 and 3. 1 and 3.
5 seconds.
CH4 and SO4 2-.
That is correct. Toss-up number 4 is in general science and it's multiple choice. Which of the following is the best reason why AM radio stations are generally heard better at night than during the day? W, the bottom layers of the ionosphere disappear and the layers above reflect the radio waves very effectively. X, AM radio waves typically travel faster in colder nighttime air. Y, all AM radio stations are required to transmit at a different bandwidth at interrupt. B2.
Z.
I'm sorry, it's incorrect. This interrupt, I'll repeat for Team A. Toss-up, general science, multiple choice. Which of the following is the best reason why AM radio stations are regularly heard better at night than during the day? W, the bottom layers of the ionosphere disappear and the layers above reflect the radio waves very effectively. X, AM radio waves typically travel faster in colder nighttime air. Y, all AM radio stations are required to transmit at a different bandwidth at night. Z, UV radiation causes daytime static in the AM wavebands. A1.
W.
W is correct. Your bonus question is visual in general science. Short answer. Answer the following 2 questions regarding this chart. 1, how many quads were produced by fossil fuel sources in 2008? 2, how many quads to the first decimal place were produced by renewable sources in 2008?
5 seconds.
83.9 and 15.9.
Sorry, the answer is 58 and 7.4. Toss-up number 5 is in earth science multiple choice. During a positive North Atlantic oscillation, or NAO, Atlantic storm tracks will most likely W, track north and be stronger than normal, X, track north and be weaker than normal, Y, track south and be stronger than normal, Z, track south and be weaker than normal. A, Captain.
W.
Is correct. And your bonus question in earth science is short answer. Giving your answers as high or low, what type of atmospheric surface pressure is typically present at Earth's latitudes of 0 degrees, 30 degrees, 60 degrees, and 90 degrees, respectively?
So it's where it's saying, so this is low, high,
5 seconds.
low, high, low, high.
That is correct. Toss-up number 6 is in astronomy, and it is multiple choice. Assuming clear skies, if a second quarter moon occurs on January 30th, on which of the following days of the same month would it be most advantageous to observe a magnitude 5 star with the unaided eye at midnight? W, January 9th. X, January 15th. Y, January 27th. Z, January 30th. A, Captain.
W.
That is incorrect. B, Captain.
January 15th.
That is correct. Your bonus question is visual in astronomy, and it's short answer. Answer the following 3 questions. 1. What is the most common name for this stellar process? 2. What do the letters A and B represent respectively? And 3. What does a small white round ball represent that is emitted in 2 of the steps and shown in a legend?
What's the process?
5 seconds.
CNO cycle. Nitrogen. Oxygen. Positron.
I'm sorry, it's C and O. A is gamma rays, B is neutrinos, and the last one is positrons. Toss-up number 7 is in math, and it's multiple choice. A fair die is rolled 6 times. Which of the following best describes the probability that all 6 numbers are rolled? W, 5 factorial divided by 6 to the 5th power. X, 5 factorial divided by 6 to the 4th power. Y, 4 factorial divided by 6 to the 5th power. Z, 4 factorial divided by 6 to the 4th power. A3.
5 factorial divided by 6 to the 5th power.
That is correct. Your bonus question in math is visual, short answer. Pick's theorem is used to calculate the area of polygons where each vertex is on a grid of equally spaced points. A polygon is pictured in the standard coordinate plane. What are the 2 missing values, A and B respectively, from Pick's theorem for this polygon?
If the coordinates are something, just to find the area, yeah. Count vertical and horizontal. Total horizontal distance over vertical. No, they're with 6 over and
5 seconds.
A equals 4, B equals 6.
I'm sorry, A equals 8 and B equals 9. Toss-up number 8 is in physics, and it's multiple choice. Which of the following is an acronym for the type of non-baryonic matter that is believed by many cosmologists to account for much of dark matter? W, MRFs. X, DINS. Y, surfs interrupt. A, Captain.
Z.
WIMPs is correct. And your bonus question in physics is multiple choice. Which of the following principles is tested by measurements on entangled particles? W, special relativity. X, general relativity. Y, Bell's inequality. Z, Lorenz's theorem.
Y.
That is correct. Question 9 is a toss-up for both teams in earth science, multiple choice. Facility is a property common to W, siltstone. X, sandstone. Y, mudstone. Z, shale. A, Captain.
Z.
Is correct. And your bonus question in earth science is visual and short answer. Identify which of the specimens labeled A through D, respectively, are the following 4 minerals: bauxite, stibnite, fluorite, tremolite.
Yeah. You're good, yeah.
5 seconds.
B, C, D, A.
That is correct. Toss-up number 10 is in biology and it's multiple choice. Which of the following is not true regarding genetics? W, a recessive allele will usually not be phenotypically expressed in the presence of a dominant allele. X, sister chromatids separate in mitosis and meiosis. Y, linked genes will typically cause a divergence from the expected ratio interrupt. B, captain.
Z.
Is correct. Your bonus question in biology is visual, short answer. Answer the following 4 questions. This chart illustrates the response a person has to a sudden, exceedingly dangerous situation, such as a speeding car nearly upon him. Tell whether the nervous system messages labeled 1 and 2 respectively are increased or decreased, and whether the boxes at 3, 4 respectively undergo an increase or decrease.
So heart rate 3 increases for sure. Heart rate increases. Blood pressure increases.
decreases.
Does it?
Okay, so is it like up, down?
Increases, decreases. Yeah. So increases, decreases.
Increases, decreases, increases, increases.
I'm sorry, it's decrease, increase, increase, increase. Toss-up 11 is in general science, multiple choice. Which of the following is the greatest barrier to high-efficiency LEDs that emit bright white light? W, most phosphors that are efficient are toxic. X, heat loss from Stokes shift. Y, the most efficient LEDs emit light in the red spectrum. Z, RGB combinations to produce white light commonly overheat. A2.
Z.
I'm sorry, that's incorrect. B, captain.
Y.
I'm sorry, the answer was X, heat loss from Stokes shift.
And that's the half.
And scorekeeper, the score at the half is?
The score is North Carolina's 68 and Miraloma 26.
Thank you. We'll now have a brief 2-minute break in between halves.
You started that last question like 1 second. So
I wanted to try this.
I was watching during question 10 and trying to.
I was trying to time it. I saw the clock on like 26.
Yeah, I was getting ready to let you know if it didn't expire. Yeah.
If everyone could please take their seats again, we'd like to resume with the second half of competition. Please take your seats. All right, thank you very much. We've gone through 11 questions in the first half. The score is 68-26, is that correct? We're going to resume with question number 12. Before we do we have any substitutions on either side of the table? Okay, well then without further ado, let's continue with the second half of our finals. This is toss-up question number 12. It's in chemistry and it is multiple choice. Which of the following is closest to the root mean square velocity in meters per second of oxygen molecules at 300 Kelvin? W, 484, X, 670, Y, 826, Z, 1000. B1.
X.
I'm sorry, that's incorrect. A2.
Z.
I'm sorry, it's actually W, 484. Toss-up number 13 is in physics and it is multiple choice. If the density of matter is less than critical density, the universe is interrupt. B, captain.
Open.
I'm sorry, it's incorrect. It's interrupt. I'll repeat for team A, toss-up, physics, multiple choice. If the density of matter is less than critical density, the universe is W, closed and finite, X, open and finite, Y, closed and infinite, Z, open and infinite. A2.
Z.
Z is correct. Your bonus question in physics is visual and it is short answer. Answer the following 3 questions. 1. What is the most common name for the general type of radiation produced by this facility that is located at one of the Department of Energy national laboratories? 2. What is the common name that scientists use for the devices depicted as orange rectangles in the upper frame and illustrated in the lower diagram? 3. What is injected into the linac where the finger is pointing?
Seconds.
Synchrotron radiation, solenoids, electrons.
I'm sorry, it's synchrotron, undulators, and electrons. Toss-up number 14 is in math, multiple choice. Which of the following is a simplification of the given infinite series? 1 plus sine squared theta, plus sine to the 4th theta, plus sine to the 6th theta, plus dot, dot, dot. W, tangent squared theta. X, cosecant squared theta. Y, secant squared theta. Z, cotangent squared theta. A3.
Cosecant squared theta.
Sorry, that's incorrect. B, captain.
W.
I'm sorry, the answer was Y, secant squared theta. Toss-up 15 is in astronomy and it is short answer. What specific type of stellar distance marker was most useful in helping scientists in 1998 conclude that the universe interrupts B, captain?
Type 1a supernovas.
That is correct. And your bonus question in astronomy is visual, short answer. This is a graph of the Milky Way's expected and actual rotational curve. Answer the following 3 questions. 1. If the sun is the yellow and orange circle, how many kiloparsecs is it from the galactic center rounded to the nearest whole number? 2. Which colored line represents the expected rotational curve? And 3. What is most commonly proposed as being present in the galaxy and causing differences between the red and blue lines?
Is it 8? Wow. Yeah, go with 8. Go with it. Yeah, go with it. Okay. Go with it.
8. Red. Dark matter.
That is correct. Toss-up number 16 is in chemistry and it's multiple choice. Graham's law of diffusion was the basis for the development of which of the following processes? W. Dialysis for renal failure. X. Reverse osmosis used in the conversion of salt water to fresh water. Y. Separation of U-235 from interrupt A, captain.
Y.
Is correct. And your bonus question in chemistry is short answer. A coffee cup calorimeter is used to determine the specific heat of a metal. If 20 grams of metal are heated to 100 degrees C, then dropped into a cup containing 75 grams of water at 20 degrees C, the final temperature of the water becomes 22 degrees C. Find the specific heat of the metal expressed in joules per gram degree Celsius to the first decimal place. Assume all heat is transferred to the water.
Is it 22 degrees?
Yeah, so wait, it loses heat?
Doesn't make sense.
No, it gains.
Wait, it went
The water gains.
It was 20 degrees,
20 to 22. It gains heat.
5 seconds.
0.3.
I'm sorry, the answer was 0.4. Toss-up 17 is in astronomy, and it is multiple choice. In the Sun-Earth system, which of the following best describes Lagrangian point 3, or L3? W, geosynchronous with Earth. X, on the opposite side of the Earth. Interrupt. B, captain.
X.
I'm sorry, it's incorrect. It's an interrupt. I'll repeat for Team A. Toss-up astronomy, multiple choice. In the Sun-Earth system, which of the following best describes Lagrangian point 3, or L3? W, geosynchronous with Earth. X, on the opposite side of the Earth. Y, on the opposite side of the Sun. Z, 60 degrees behind the Earth as it orbits the Sun. A2.
Z.
I'm sorry, it's Y on the opposite side of the Sun.
Excuse me, I'd like to challenge that, please.
Stop the clock, please.
On the opposite side of the Earth can be interpreted as on the other opposite side of the Earth's orbit, as I interpreted it.
I'm sorry, so your challenge is that?
Is that it
Can you rephrase it,
should
please?
also be on the opposite side of the Earth, because I interpret it as the opposite side of the Earth's orbit. That is ambiguous.
All right, we will consult. Please wait.
There are, of course, I expect you know that there are Lagrange points, and there's one on the opposite side of the Earth from the Sun and one on the opposite side of the Sun from the Earth. The Earth and the Earth's orbit are very much not synonymous, and so in this case we're going to reject your challenge.
Sorry, so
So, no, they both got it incorrect, I believe. Yes, they both got it incorrect. So we're going to
Okay, so both teams have. Sorry. Okay, so that was question number 17. Both teams answered. Both teams got it incorrect. So we'll now move on to toss-up question number 18. It's in general science and it's multiple choice. Which of the following best describes an exciton? W, the bound state of an electron and an electron hole. X, the higher energy state of an electron. Y, an electron that has absorbed radiation but not moved to another energy level. Z, a proton at near 0 Kelvin that is behaving like an electron. B1.
Y.
I'm sorry, that's incorrect. A1.
X.
I'm sorry, it's W, the bound state of an electron and an electron hole. Toss-up number 19 is in earth science, and it is short answer. What is the more current name used by many researchers for the Cretaceous Tertiary extinction event? A, captain.
KT extinction.
I'm sorry, that's incorrect. B, captain.
The Great Asteroidal Impact Event.
I'm sorry, it's the Cretaceous Paleogene, or the KPG. Toss-up number 20 is in biology, multiple choice. Which of the following best accounts for why some antibiotics that inactivate bacterial ribosomes do not overly affect the host animal? W, the host is much larger and this would require much higher concentrations. X, bacterial ribosomes have different interrupt. B2.
X.
That is correct. Your bonus question in biology is short answer. By words or number, name all of the following 4 choices that would be unlikely to occur during the first half-hour period of running a marathon. 1. Increase in end diastolic volume. 2. 40% increase blood flow to the stomach and small intestine. 3. 10 to 20% increase in plasma thyroxine levels. 4. Increased mean arterial blood pressure.
Unlikely. What's unlikely? What's 3? That's likely. And then 4 is also likely? And what about the diastolic?
5 seconds.
2 only.
I'm sorry, it's actually 2 and 3. Toss-up number 21 is in math and it is short answer. A parametrized path in the xy plane is given by the equations x equals 3t and y equals t squared. What is the velocity vector at t equals 1? A3.
3, 2.
That is correct. Your bonus question in math is short answer. An unfair die, when rolled, shows a 6 with probability of 1/2. The probability of rolling a 5 is 3 times that of rolling a 4. The probabilities of rolling a 1, 2, 3, or 4 are all equal. What's the probability as a fraction in lowest terms of rolling a 1?
112. I got 114. I got 112. It's definitely 1.
I got 114. Make sure. 1, 2, 3,
Oh, wait.
and 4. It's 114.
Pretty sure it's not
5 seconds.
114.
114.
That is correct. Toss-up number 22 is for both teams in physics. It is short answer. Name all of the following 4 choices that are typically considered easy to explain when light is considered as a wave. Diffraction, photoelectric effect, polarization, refraction. A captain.
1, 3, 4.
Is correct. Your bonus question in physics is short answer. Consider a metal that has a linear coefficient of expansion of 23 times 10 to the negative 6th per Kelvin. Assuming that this quantity is constant over the relevant temperature range, by how many millimeters to the nearest whole number will a 35-meter-long rod of this metal expand if it is evenly heated from 1 degree C to 16 degrees C?
16 times 10 to the minus 3 is my guess. And that's in meters, right?
So
in millimeters.
16 millimeters. Give an idea what you're doing.
I just multiplied them together.
5 seconds.
16 millimeters.
Sorry, it's actually 12.
Oh, man.
Toss-up 23 is in chemistry and it is short answer. Identify each of the following 3 steps that occur in the solvation process of solution formation as being either endothermic or exothermic. 1. The separation of solute particles from one another prior to dissolving. 2. The separation of the solvent particles from one another prior to dissolving. 3. The combining of interrupt, B captain.
Endothermic, endothermic, exothermic.
Is exactly right. Your bonus question in chemistry is visual, short answer. Answer the following 3 questions with the letters A through D. 1. Which molecule reduces fluidity in the typical animal cell plasma membrane? 2. Which molecule would be found in the lowest amounts in a typical animal cell plasma membrane? 3. Which molecule has been most directly associated with a lower dietary risk of cardiovascular disease?
It's this one. This one. C. It's BAC.
BAC.
I'm sorry, it's BDC. Toss-up number 24 is in biology and it is short answer. By words or number, name all of the following 3 choices that are true regarding P53. 1. It is a protein. 2. It is a tumor suppressor. 3. It regulates the self-interrupt. B captain.
1, 2, 3.
Is correct. Your bonus question in biology is visual, short answer. Answer the following 3 questions. 1. What is the most accurate name microbiologists use for this culture plating technique? 2. If you were to overlay an analog clock upright over this image, at what time would the bacteria first have been applied? And 3. What is the most common name for the round objects at the ends of the lines labeled with the letter A?
5 seconds.
Selective spreading, 7 o'clock, and colonies.
I'm sorry, it's streak plate, streaking, 9 o'clock, and colonies. Toss-up number 25 is in chemistry and it is short answer. How many sigma and pi bonds respectively are contained in the molecule with the following structural formula? CH2, C, CH2. A captain.
6, 2.
That is correct. And your bonus question is in chemistry, short answer. Convert 80 parts per billion of calcium-2 ions into molarity units. Assume the atomic mass of calcium-2 plus is 40, and give your answer in scientific notation to one significant digit. Sorry, the correct answer was 2 times 10 to the negative 6th. And that's the end of the match. The final score is North Carolina 106, Mira Loma 52. I'd like to congratulate our 2010 National Science Bowl high school champions, North Carolina. Let's have a hand for them, please. We will now have a brief break while we set up for the middle school 2010 National Science Bowl finals. Thank you. Topographic area possible.
The courtyard is one of our central themes, obviously, and we have the house wrapping around it. So basically what we did to come up with a strategy for a very small footprint, for occupying a very small livable space interior, was to start occupying the exterior, and we made a courtyard with a 4th room. All of our pocket doors slide into the wall so that the balcony space and the living room space actually jut out and sort of combine. So you're actually standing in the interior and the exterior, and it's easy to go between. We've created a lot of really nice moments.
We also use an innovative material called warm board in the floor. It's a radiant heating system in which it also acts as the subfloor for the structure, and it also has tubes of running water in it that actually heat up the floor and in the environment of the inside of the house.
All of our landscape is a zero-scape, which means that you don't use any water. They'll survive in what their site gives them. Another cool thing is we've made our PVs very sexy. I think we've succeeded in not just putting sort of a flying nun's hat on a roof or on a building, but we've actually made them accentuate the gesture of the house and really work well with the house. We made a continuous plane, so they are a complement to the architecture.
The gable home is based off the premise of our house. It's a vernacular architecture that's traditionally Illinois, a symmetrical gable that you'd see in rural throughout the Midwest. We tried to approach the project with a number of different ideas, and one of the main ideas was showing that you can have old ideas with new technologies. So the exterior of our house is reclaimed wood, both from a barn and then from a silo locally. And then we made the structure out of a brand new product called that's laminated bamboo that is the full structure. And then inside we have new appliances, new materials, new technologies. It's really trying to show that you have an old idea and an old vernacular with all the new technologies, that intermixture is possible. Our house is designed so that it's a Passive House certified home, which means it uses 90% less electricity for heating and cooling than a standard house. And we also wanted to show that solar panels don't need to dominate the entire roof. So you'll notice that our house only has half our roof faced towards the south. We're able to show that you can use a symmetrical roof, which is more standard, and still generate enough power to produce all you need for the house. Inside the home, we tried to design it to be a fully functional house. They'd be comfortable both for a couple as well as for entertaining for a larger group of people. But we also want to make it flexible. So we have materials that are new, that use a minimal amount of material. We have a very thin cabinetry. We have very efficient appliances. Our engineers designed a custom HVAC unit that utilizes the hot water tank to cool the house. And so there are a lot of different ideas melded together in order to create a small house. It's only 516 square feet, but that feels very functional and very comfortable. I think the greatest part about the Solid Decathlon is really the collaboration between many different people. I'm from architecture, and we don't always talk to the engineers at school. We don't talk to the business or the communications. And this type of project really brings everyone together, brings out new ideas, and really helps us grow towards a better goal.
Well, the style is pretty easy because having the surface ratio in an optimal way, it's very important to minimize the surface of the building to prevent the surface that can have heat bridges or something like that. So the best way for sustainable design in general is to minimize this ratio, and this would be the cubish form. This is why we showed up with this shape. The dark materials on the facade are polycrystalline photovoltaics, right? We use them as an overall concept. We have them on all of the facade, even on the northern side, because this type of photovoltaic is also able to produce energy by indirect sunlight. So the main issue if you create a solar house is always the northern facade, because you don't have that impact on it as you have it in the southern facade. One of the most things people will recognize if they enter the house is that the whole building creates one big room. There are no straight separations in between rooms. We created more like zones, right? We have all the functions covered, like bathroom, bedroom, living, dining, kitchen, and also created a second story. We integrated a heat pump that uses also the exterior air and exchanges the heat over to, well, it can switch. It can give this heat energy over to the warm water tank, but it can also give this energy to the influent to the fresh air that's going inside of the building. Yeah. This element is also able, in case it's getting the heat over to the warm water tank, it will produce cold energy that is provided to the room. So this one heat pump is able to cool and heat in an active way. I am totally happy. I'm totally happy, and I can't wait to start the competition.
We decided to come up with the idea of trying to integrate everything together as one unit, and we started coming up with words that said that, and we came up with natural fusion. We feel there's this disconnect between the natural environment and then the built environment that we created. So we'd like to try to blend the two back together. We've done that through a couple different circumstances. We have a life well inside of our house and a living wall on the north side. The coolest outside features has to be our solar systems. Right now we've got our roof system, which is a different system than any other school has on the National Mall this year. It's cylindrical solar panels made of a thin film material, SIGs. The cool thing about these is with a cylindrical design, no matter where the sun is, it's always perpendicular to the surface of it. So you're getting a lot more collection in the morning and evening. We're also getting reflection through that off the roof onto the underside of the cylinders. The green roof will help cool it.
Could we please have the two middle school Science Bowl finalists, Albuquerque Academy and Gale Ranch, please come to the stage. Thank you very much. And everyone else, if you could please be seated. We're about to get started with the finals of the Middle School 2010 National Science Bowl competition.
Ladies and gentlemen, it is my distinct honor to present to you the First Lady of the United States, Michelle Obama, and Secretary of Energy, Dr. Stephen Chu. A nice, warm Science Bowl welcome. And we have our teams in place. Our competition is about to begin. Let me introduce to you our team. Our science judge for the middle school competition is, again, Adam Matthews. Our moderator, again, Dean Jens. Our timekeeper, Cindy Dalton. Our scorekeeper, Nancy Marlin. And not to make you all nervous, teams, but the lead science judge is none other than Nobel laureate Secretary Chu. And not to put any more pressure on you, but the moderator for all of the bonus questions will be none other than the First Lady herself. Adam, would you be good enough to go over the rules and get our competition started?
All right, thank you very much, everyone. This is very exciting. We just finished with the 2010 National Science Bowl High School competition, and now we're going to commence with the finals of the 2010 Middle School competition. We have both the teams on stage. So at this point, I'll turn the mic over to Dean Jens, who will introduce the officiating staff and tell us how the competition will be running.
Okay, my name is as introduced, is Dean Jens. I was an alum here. I competed in the National Science Bowl in '92 and '93, and competed in the Regional Science Bowl in its very first year in '91. I will be reading the toss-up questions here, and the First Lady will be reading the bonus questions, and I'll have the other, well, two of our judges need no introduction, but we'll go ahead and have the rest of them introduce themselves.
Good morning. My name is Adam Matthews. I'm a Science Bowl alum. I was here for the high school competition in 1995 and 97 from Punahou School in Honolulu, Hawaii. I did my undergraduate degree in biochemistry at Harvard, a PhD in immunology, and I'm currently a research fellow at MIT. I will be your secondary science judge, and I will be ruling on the toss-up questions in terms of whether they're correct or incorrect, and Secretary Chu will be ruling on the bonus questions. And can we have the timer and scorekeeper please introduce yourselves?
Cindy Dalton, IBM, and I'll be your timekeeper.
Nancy Marlin, DOE, and I'm your scorekeeper.
Okay, and now we would like to have the team members introduce themselves, and you know how we do that with our buzzer check. So I would like you to buzz in, starting from this side of the stage and moving over towards this side. I will recognize you, which I will do on the toss-up questions during the match. Go ahead and buzz in, and I will recognize you, and you can tell us your name and tell us what you want to do when you finish school and hopefully as a career. Team A3.
I'm Jason, and I'd like to go into economics later.
Team A2.
I'm Ben, and I'd like to go into medicine.
Team A, Captain.
I'm Eric, and I'd like to go into medicine as well.
Team A1.
I'm Andy, and I'm undecided, so.
Team B1.
I'm Siren, and I would like to become a scientist.
Team B, Captain.
I'm Augustine, and I'd like to go into neurology.
Team B2.
I'm Rishi, and I'm undecided.
Team B3.
I'm Ayush, and I'm undecided.
Okay.
Could I please ask participants to speak into the microphones? We have a very large auditorium here, and it's very hard for everyone to hear you unless you speak directly into the microphone. Thank you very much.
And likewise, similar, certainly make sure that if you can't hear me, you let me know, and I'll try to fix that. Are we good?
Are you guys ready to go? As relaxed as you're going to be? All right.
Okay. Well, let's begin then with double elimination round number 8. Toss-up question 1, which is in physical science, multiple choice. Which of the following best describes a thermodynamic isolated system? W. Exchanges only energy with its surroundings. X. Exchanges no energy with its surroundings. Y. Exchanges no mass with its surroundings. Z. Exchanges nothing, that is an interrupt by A1.
X.
Sorry, that's incorrect.
I will reread for Team B. Which of the following best describes a thermodynamic isolated system? W. Exchanges only energy with its surroundings. X. Exchanges no energy with its surroundings. Y. Exchanges no mass with its surroundings. Z. Exchanges nothing, whether it is energy, matter, or work, with its surroundings. B1.
Z.
That is correct.
So now you have a bonus question. This is physical science. It's a short answer. Give the net ionic equation between aqueous solutions of HC1 and NaOH.
I'm sorry, HCl.
HCl.
I think that's it.
Five seconds.
HCl plus NaOH yields NaCl plus H2O.
Incorrect. It's the net aqueous solution of it's the net ionic equation between aqueous solution. It's H plus OH minus equals water.
So we'll move on to toss-up number 2, which is an earth science multiple choice. Which of the following is most accurate regarding the release of carbon dioxide into the atmosphere by human activity versus volcanoes on a yearly basis? W. Human activity releases less CO2 into the atmosphere than volcanoes. X. Human activity releases more CO2. That is an interrupt by A Captain.
X.
Is correct.
All right, your bonus question, it's earth science multiple choice. One way a fin is different from a bog is that a fin is typically W, not stagnant, X, brackish, Y, acidic, Z, fed by permafrost meltwater.
Okay, I think it's W. I don't think it's.
It's not a
Okay,
Did they ask for the fin?
Yeah.
Okay,
So
so-
W. I was thinking W or Z.
I think it's W.
I'll go W.
All right. W.
Correct.
Toss-up number 3, math, multiple choice. Cube A has a surface area of 216 square centimeters, and cube B has a volume of 216 cubic centimeters. Which of the following is the ratio of the edge lengths of cube A to cube B? W, 1 to 1. As an interrupt, Team A1.
W.
Is correct.
Okay, your bonus question is math short answer. Find the coordinates of the point of intersection of the lines given by the following two equations. 2x minus 3y equals 11, and 3x minus 2y equals 14.
All right, hold on a sec.
X. What is equal to
5 seconds.
1, 3.
Sorry, that is incorrect. It's x equals 4, y equals minus 1.
So we move on to toss-up number 4, which is in general science multiple choice. Which of the following would be least likely to be seen by a stargazer at 45 degrees north latitude? W, the constellation Taurus near the ecliptic. X, the planet Venus at dawn low in the eastern sky. Y, the Big Dipper setting below the horizon? Z. Altair high in the summer sky. A. Captain.
Z.
That's incorrect.
B2.
W.
I'm sorry, that's also incorrect. The correct answer was Y, the Big Dipper is setting below the horizon.
Toss-up number 5, life science, multiple choice. Which of the following are the 3 substituents that make up an RNA nucleotide? W, a base, a 6-carbon sugar, and an ATP molecule. X, a base, a 5-carbon sugar, and an ATP molecule. Y, a base, a 6-carbon sugar, and a phosphate molecule. Z, interrupt, B. Captain.
Z
is correct.
The bonus question, life science, short answer. A sample of human blood is taken and the cells are separated from the fluid part of the blood. The cells are all burst open and the proteins are analyzed and identified. What is the most common protein in the sample, and is it a globular or fibrous protein?
Hemoglobin, globular.
That is correct.
Toss-up question 6, physical science, multiple choice. Which of the following is true regarding a ray of light when it passes from a vacuum into glass? W, the frequency changes but the speed remains the same. X, the wavelength changes but the frequency as an interrupt, B1.
X.
That is correct.
Okay, physical science, short answer. In the photoelectric effect, incident light of a certain color will emit no electrons from a zinc plate. By words or number, name all of the following 3 choices that will cause the emission of electrons. 1, increase the brightness of the light. 2, change the angle of the incident light rays. 3, increase the frequency of light.
Five seconds.
3.
That is correct.
Toss-up question 7, earth science, multiple choice. The power or magnitude of an aurora depends mostly on which of the following? W, variations in Earth's magnetic field. X, the strength of the solar wind. There's an interrupt, A. Captain.
X.
That is correct.
Your bonus question is multiple choice. As part of the EarthScope project, the SAFOD is studying the San Andreas Fault in California by doing which of the following? W, monitoring ozone levels along the entire length of the fault. X, installing geomagnetic observatories along the entire length of the fault. Y, drilling a 3.2-kilometer borehole into the fault. Z, measuring temperature changes in fumaroles deep within the fault.
Alright, so is monitor or
Definitely not.
what?
So what? Y then? Alright, should I go with Y?
Sure.
Alright. What do you think?
I don't think it's mine.
Okay. What do you
5 seconds.
I'll go with Y. Y.
Y is correct.
Toss-up 8, math, multiple choice. 3 digits are chosen without replacement from the set 2, 3, 6, and 9. The digits are then placed in random order to form a 3-digit number. What is the probability that this 3-digit number is divisible by 3? W, 1 over 24. X, 1 over 12. Y, 1 over 6. Z, there's an interrupt, A1.
Z.
That is correct.
Your bonus question, math, short answer. Circle X has radius pi, circle Y has circumference 8 pi, and circle Z has area 27. List the circles in order from largest to smallest.
Pi, they say, and then square root of this. Alright, so what did they say? What was the question they asked?
Biggest to smallest.
Biggest to smallest. Alright, so that's about. What's 27?
5 seconds.
Alright. Smallest to largest?
Yeah.
Alright, so this one.
Time.
X, Y, Z.
Sorry, that is incorrect. Y, X, Z.
Toss-up 9, general science, multiple choice. Which of the following is the Milankovitch theory most directly involved with? W, artificial intelligence. X, climate change. Y, origin of life. Z, string theory. A, captain.
W.
Sorry, that's incorrect.
B1.
X.
That is correct.
Your bonus question, general science, short answer. By words or numbers, name 2 of the following 4 choices that are primary factors in the Milankovitch cycle. 1, Earth's precession. 2, the solar cycle. 3, variations in the inclination of the Earth over 41,000 years. 4, nutation of the moon.
Precession.
5 seconds.
2 and 3.
Sorry, 1 and 3.
Okay, and that is the half.
Scorekeeper, please read the score at the half.
At the half, the score is Team A 36 and Team B is 40.
Thank you. We'll now have a 2-minute break before resuming with the second half of competition.
We're still in this round, and we're going to go to one here. Yeah, so yeah, you're doing. Get settled, please. Those of you who are standing, please take your seats. Well, not the officials, you know. You know who you are if you're supposed to be standing. Were there any substitutions up here during the halftime? Okay. And we finished on question 9. Is that right, Adam? That you were ready for number 10, right?
That's correct.
I like to make sure that we get the right questions here. Okay, so let's begin then with toss-up question number 10, which is in life science multiple choice. Which of the following mostly accounts for why bacteria do not typically grow on honey? W, osmotic water has an interrupt by A, captain.
W.
That is correct.
Your bonus question, life science multiple choice. Which of the following best describes what the letters and numbers H1N1 refer to in the flu virus? W, forms of enzymes in the virus, X, where and when the virus arose, Y, molecules on the outside of the virus, and Z, types of nucleic acid in the virus.
Y.
Y is correct.
Toss-up question 11, physical science multiple choice. Which of the following best describes the most important clue to why Rutherford and coworkers decided most of the mass of the atom was in the nucleus? W. Alpha particles were helium nuclei that had been released during radioactive decay. X. During bombardment of foil with alpha particles, there's an interrupt by A captain.
X.
That is correct.
Your bonus question, physical science, multiple choice. If an atom absorbed in a single alpha particle, it would, W, change into a new element and increase its atomic number by 2, X, remain as the same element and increase its atomic mass by 4, Y, change into a new element and increase its atomic mass by 2, Z, remain as the same element and increase its atomic mass by 2.
W is a new element.
It has to take two
Well, it has to
protons,
take-
right? So
Oh,
that
good
makes
point,
sense.
because alpha particles.
Right,
are
should we do W?
I suppose.
W.
W is correct.
Toss-up 12, earth science multiple choice. If we assume the average diameter of a raindrop is 2 millimeters and the average cloud droplet diameter is 0.02 millimeters, which of the following would best describe the diameter of the average condensation nucleus in millimeters? W, 0.0002, X, 0.02, Y, 0.01, Z, 0.2. A captain.
Y.
I'm sorry, that's incorrect.
B2.
Z.
I'm sorry, that's also incorrect. The correct answer was W, 0.0002.
Toss-up 13, physical science multiple choice. As you move from left to right across period 4. Okay. As you move from left to right across period 4 on the periodic table, the first 3 elements, potassium, calcium, and scandium, progressively become W, softer with lower melting points. X, harder with lower melting points. Y, softer with higher melting points. Z, harder with higher melting points. A captain.
Z.
That is correct.
Your bonus question, physical science, multiple choice. Which of the following best explains the steady increase in hardness and melting point for the first 6 elements of period 4? W, increasing number of neutrons prevents nuclear destabilization. X, increasing number of valence electrons leads to stronger molecular bonding. Y, increasing atomic number leads to increases in atomic ionic radius. Z, increasing size of the nuclei allows for greater packing of the atoms in the crystal lattice.
I think it's X or Z.
Okay.
I suppose
I think it's X, yeah.
I think it's X.
X.
X is correct.
Toss-up 14, general science multiple choice. Which of the following telescopes typically has the lowest resolving power? W, X-ray. X, reflector. Y, radio. Z, refractor. A captain.
Y.
That is correct.
Bonus question, general science, multiple choice. Which of the following is the most direct cause of the relatively poor resolution of a radio telescope? W, the large size of the dish. X, the long wavelengths in which they operate. Y, the interference with the Earth's atmosphere. Z, interference by the solar wind.
I think it's X.
Wait, long wavelength?
Yeah.
Good point. Yeah, I was thinking so too.
X.
X is correct.
Toss-up 15, life science multiple choice. Which of the following best explains why a single base mutation in the DNA that codes for a protein will not always result in a change in the amino acid sequence of the protein? W, most mutations cause the gene to be non-functional. X, multiple codons can code for the same amino acid as an interrupt, B1.
X.
That is correct.
Your bonus question, life science, short answer. By words or number, name all of the following 3 functions for which the human vermiform appendix, located at the end of the small intestine has been shown to provide 1. Supporting the immune system, 2. Repopulating the intestine with bacteria after diarrhea, 3. Producing red blood cells during severe anemia.
1 and 2.
1 and 2 are correct.
Toss-up 16, math, short answer. A cube is increased in size so that the surface area is 16 times as large as that of the original cube. What is the ratio of the volume of the interrupt B1?
64:1.
That is correct.
Your bonus question is math short answer. Distinct positive integers x, y, and z satisfy x plus y plus z equals 10. What is the smallest possible value for the product of x, y, and z?
Eight.
Incorrect. 14.
Challenge?
Stop the clock, please.
Um,
Would you please state your challenge?
Doesn't 1, 1, and 8 add up to 10?
No, they're not distinct.
Okay, so that was 16, right? And so now we start with toss-up question 17, Earth Science, multiple choice. Which of the following makes nor'easters in New England unique from most storms that hit elsewhere in the U.S.? W. Winds blow around the low in a counterclockwise direction. X. Their winds are out of the northeast. Y. Their moisture is fueled by the Gulf Stream. Z. They only happen in winter. A. Captain.
Y.
That is correct.
Your bonus question, Earth Science multiple choice. Which of the following best describes how a winter blizzard typically forms in the Great Plains? W. A strong low-pressure system followed by a strong high-pressure system. X. A strong high-pressure system followed by a strong low-pressure system. Y. A strong low-pressure system followed by a strong low-pressure system. Z. A strong high-pressure system followed by a strong high-pressure system.
I was thinking.
I think it's W. Low pressure and then high. Low pressure system.
Okay, what do you guys think?
I think it's W too, as opposed to the low pressure. And then
5 seconds.
W.
W is correct.
Toss-up 18, math, multiple choice. Which of the following will occur if the coastline of a country is measured with measuring sticks of various lengths? W. As longer and longer sticks are used, the coastal length measure increases. X. As longer and longer sticks are used, the coastal length measure remains the same. Y. As shorter and shorter sticks are used, the coastal length measure increases. Z. As shorter and shorter sticks are used, the coastal length measure decreases. A1.
Y.
That is correct.
Your bonus questions, math short answer. If fifth-order magic squares have 25 cells, give the magic sums of all of the magic squares composed of only integers 1 through 25.
1 through 25, so that means... Oh, okay, I have an idea. So each one's used 3 times, which means that's 25 times 6, 25 times 3.
Each one isn't used 3 times.
365, yes,
Oh, yeah, they are.
975. Divided by how many?
5 seconds.
Each one isn't.
97.
97.
Incorrect. 65.
Toss-up 19, general science, multiple choice. Ed is tested for a staphylococcus infection and is told there is a 5% chance of a false negative in the test. This generally means that there is a W, 5% chance he will not become sick. X, 95% chance that the test will not detect the staphylococcus. Y, 5% chance that even if he has a staph infection, it will not be detected. Interrupt, A2.
Y.
That is correct.
Your bonus question, general science, multiple choice. A scientist collects data on 1,000 house cats and finds that every house cat in the study was found to sleep. She concludes that all house cats sleep. This form of logic is best known as W, inductive reasoning, X, deductive reasoning, Y, responsive reasoning, Z, reasoning by reduction.
Yeah, W.
W is correct.
And that is the game.
So congratulations to Albuquerque Academy, your 2010 Middle School National Science Bowl champions.
There will now be a brief break while we get the stage set up for the award ceremony. Could we please have the high school and middle school Science Bowl champions please come up next to the stage. Some night reading.
everyone could be seated, please, after you take the final photos there, you'll have more opportunities in just a moment. What a wonderful morning it has been. What a great audience you have been. Give yourselves a nice round of applause. And you know, most First Ladies, if they would come here at all, might show up just for the taking of the pictures and the presentation of the trophies. But our First Lady, Michelle Obama, we made her work this morning, didn't we? Mrs. Obama did a fantastic job, and First Lady, you have given these young people a memory they will remember forever. Thank you so much. Thank you. And to their great credit, the two middle schools did not wilt under the gaze of the First Lady or the Nobel laureate seated right to her left. Wonderful. Thank you, Secretary Chu. And now the presentation of the prizes and the trophies to our ultimate winners. We're so proud of them. First of all, our high school champ, making their first appearance ever here at the National Science Bowl. Never in 20 years have they been here. What a splash they have made. What a wonderful coming out party for the North Carolina Science and Math School. Our winner from Durham, North Carolina. Each member of the team receives a trophy. $1,000 goes to the school's math and science department. Each team member also receives a Texas Instruments Inspire calculator and an Inspire Teacher's Edition, a SmartView, and three, count them, computer-based lab data collection systems courtesy of Texas Instruments. And most significant of all, they are all going on a science research trip to the Central American country of Belize. Congratulations to all of you guys. You'll have a wonderful time on the volcanoes down there. You're going to the beach, and don't forget that line that goes through the trees in the rainforest. You're going to have a great time. Also, we'd like to congratulate the runner-up, which was last year's champion. A nice hand for Mira Loma High School from Sacramento. And now to our middle school winner. This is the first time in Science Bowl history that the middle school competition has been held the same time as the high school competition. And the second place winner, Gale Ranch Middle School from San Ramon, California, their first time ever. A nice round of applause for them. Terrific job. And now here they are, the 2010 U.S. Department of Energy Middle School National Science Bowl champs, the students from Albuquerque Academy, from Albuquerque, New Mexico. Look at those wide smiles. What a wonderful experience for them. Each team will receive a trophy. They receive the trophy for their school, a plaque, $1,000 for the school's math and science department, and Texas Instruments calculators, a lab data collection system, and a SmartView from Texas Instruments. Enjoy all of your winnings. Well-deserved. Albuquerque Academy. And now we're going to have some remarks from the people who made your victory possible, the First Lady and the Secretary of Energy. What I'd first like to do is pay tribute to a gentleman who's sitting out front here. Would you wave to everybody, please? Dr. Bill Brinkman. Where's Dr. Brinkman? There he is. Dr. Brinkman was appointed less than a year ago as the director of the Office of Science here at the department. They have a research budget of $4.8 billion, the largest budget for science research in this country. And you know, Dr. Brinkman, he's both a physicist, a manager, he's a researcher, a technologist, an athlete, but he's perhaps best at being living proof of that age-old advice that you should always be nice to people, especially your employees, when you're riding high. Reason being, Dr. Brinkman's during his career at Bell Labs, one of his scientists back in the 1970s in the Chemical Physics Research Lab was none other than one Stephen Chu, who would go on to win a Nobel Prize and, in a nice reversal of authority, is now Bill Brinkman's boss here at the Department of Energy. It's obviously a mutual admiration friendship. Chances are Bill let Steve take a few extra long lunches and maybe catch an NCAA basketball game on the clock once in a while. And now maybe Dr. Chu will return the favor. Bill, thank you for being here, and thank you for all you do. And now just a word about Dr. Chu himself. When the First Lady was here back in November, again for a Science Bowl event and to visit the department, she had words of praise for the Secretary. And let me quote her because I liked what she said. She said, "As you know, Dr. Chu isn't just a brilliant scientist. He's also an inspired leader. And he's bringing new ideas and perspectives to Washington, challenging all of you, all of us, to look at your own work in a whole new way. And we are so incredibly grateful for Dr. Chu's leadership. My husband loves his cabinet. He was extremely excited to have a real nerd on his team. He talked about it for weeks on end. So we are delighted to have Dr. Chu, our nerd, on the team, and we're grateful for the work that he does. All I have to say is, here he is, the Secretary of Energy. Nerds rule, don't they? Ladies and gentlemen, the Secretary of Energy, Nobel laureate, Dr. Stephen Chu.
Thank you for that slogan. I love it. Nerds do rule. And so, as you all know, be kind to nerds. They may one time be your boss. First, I'm delighted to be here. It's a thrill, of course, to be here again with the First Lady. She's so gracious, and it really adds a lot of excitement to this event, so thank you again. I want to congratulate all of the people in this room for being here, not only the winners, but all of you. I think someone said it just a few moments ago, you're all winners. It's fantastic. All the people here are really what we see as the hope in Americans' future, people who are interested in scientists, who are interested in being scholars. Now more than ever, the United States will need you and people like you to help lead us into the 21st century of economic prosperity. We look to you as future leaders. That's not to put that much pressure on you, but we are pinning your hopes to rise to all the challenges that we will be facing, and with me in particular, the energy and climate challenge that we face. So let me just say that how much the President and the First Lady and I and all the people in the administration and, quite frankly, the people in Congress believe how important it is to educate our students. As President Obama has said, improving education in math and science is about producing engineers and researchers and scientists and innovators who will help transform our economy and our lives for the better. But it's also about something more. It's about expanding the opportunity for all Americans in a world where education is the key to success. It's about an informed citizenry in an era where many of the problems we face as a nation are, at its root, scientific problems. And it's about the power of science, not only to unlock new discoveries, but to unlock the minds of our young people a sense of promise, a sense of some hard work. With effort, they will have the potential to achieve extraordinary things. So, you are off to a great start. I know that studying science is not always easy. You read a lot of textbooks. Sometimes the problems that you work in science seem like calisthenics, push-ups, if you will. They seemed like that to me when I was your age, more push-ups in college. But on the other hand, one of the things that you can look forward to, and this begins in college, in fact in many places now it begins in high school, but when you go to graduate school, if you choose to go to graduate school and keep a career in science, you will begin to do research. And when you do research, all of a sudden you're not learning things in textbooks. You are learning things that will be in textbooks. And that, to me, was a thrill. All of a sudden, I found that we don't even know what the right answer is. And we struggle, sometimes for years, sometimes for decades, to come up with the right answer. But in the end, science does come up with a deeper understanding of nature. So we want to lead by example. This is one of the other things that President Obama has said quite often. We have to convince you, the American people, but you are doing it that show young people how cool science is. Now, I also have to tell you in my personal life, and this is going to sound like a total nerd, when I was doing science and in deep, dark moments and late at night and weekends, I still go back to it only because I've become addicted to it. But when I was doing science as an active scientist, something wonderful happened. I lose track of time. I don't get hungry. My wife used to really get very upset because occasionally it would be 9 p.m. and I would look up and all of a sudden it's dark out and oops, I just missed dinner. What a wonderful thing if you do something that is so much your hobby and so much your love that you can lose all track of time and you just don't get hungry. Doesn't that sound like a total nerd to you? But anyway, it is something. Now, in terms of cool people, it's my honor to introduce the First Lady, Michelle Obama, who's an accomplished lawyer, former Vice President of the University of Chicago Medical Center, and a very cool person. She, of course, is the mother of two remarkable girls. Now, as First Lady, she's working to support military families, to help parents balance career and family, and to encourage national service. She's also taking a leadership role in an important effort called Let's Move, that's fighting childhood obesity. Well, you know that being smart is good, but what you may not know, that actually being fit helps you be smart. It really, they're parts of the same thing, being smart and being fit. And so as you do your calisthenics for your mental well-being, remember that you can also do some calisthenics, which also can be sports, which I love. But anyway, in any case, I drone on, and so, ladies and gentlemen, it's my honor to welcome the First Lady of the United States, Michelle Obama.
Oh, thank you all. Thank you so much. Thank you so much. Well, this has been a thrill for me, and let me do our winners a favor. Put those trophies down. Put them down. You've earned the right not to hold them up. But these are the real stars. It's just been a pleasure to join you here at the National Building Museum for the 20th Annual National Science Bowl. This has been a real treat. I've been looking forward to this. I got to share the stage with Secretary Chu earlier in this year, who is not only one of the world's leading scientists, but also, as you all know, a visionary leader for our Department of Energy. And he may just have an alternative career as a game show host when he's done with this. He's really good at it. But we're very proud to have Secretary Chu on our team. He's doing a tremendous job, and he is an example of the concrete outcomes that come with the work that you're doing today. This is why we need to invest in you all so much, and we're so very proud of you. Also to all of the organizers, all of the volunteers, to the teachers, let's give our teachers a round of applause. And we can't forget all of the family members who are here. I know there are people in the back. Let's give our parents and family members a round of applause. You all are all the true winners here. Thank you for giving your time, your support to this next generation of American innovators, scientists, and entrepreneurs. And finally, last but not least, congratulations again to the two winning teams and to every single student here who has participated in this year's National Science Bowl, both here in Washington and in your hometowns in the months leading up today. Again, we can't tell you how proud we are of the hard work that obviously requires putting into something like this. I had to study just to read the questions, so I know you all have put in a lot of work. But by competing in this event, you are sharpening the skills that have consistently moved our country forward. This is the profession that has done it in so many ways. Creativity, discipline, teamwork, problem solving, and a whole lot of hard work. And that's what it takes to make change. You've worked so hard, and again, the President and I, and he is fully aware that I am here. I went over some of the questions with him. He didn't know many of the answers, but that's okay. Neither did I. But we are both so very proud of all of you. We believe deeply in the importance of science and math. This is an important investment in this generation and beyond for the future of this country. And this year, we're going to host the first ever White House Science Fair for students from all across the country. As the President has said, he says this all the time. He says, when you win the NCAA championship, the winners come to the White House. And we think that budding inventors, scientists, and mathematicians should be at the White House too. So we're going to be excited to host you there. As many people have already said, we're determined to show the world and this country how cool science can really be. We want young people energized in the way that you all are, because we know that American brain power in science and math has always driven this country's prosperity, helping us make the discoveries and to build the industries that have transformed the way we live and work. That's why my husband and his administration want to ensure that every single child in this country gets a good education, particularly in math and science. Next week's National Lab Day is a great example of what this might look like, this kind of investment. The President has highlighted his grassroots effort, which brings together scientists like Secretary Chu, organizations representing teachers, scientists, mathematicians, engineers, and local volunteers to work with young people in fun, hands-on learning. These students are going to be with us. They're going to launch rockets, construct miniature windmills, and learn by doing and not just by listening. We want to bring more hands-on learning like this to students by also modernizing science labs and supporting project-based learning and expanding advanced courses in schools throughout the country. We want to create more opportunities for underrepresented groups as well, particularly women and girls. We want them to have the confidence We want all our young women to have the confidence and the support to take on the study and to succeed in the study of science, math, engineering, and technology. And we want to build communities of support for all the teachers who make these subjects come alive for our students. We couldn't do it without you. And just a few minutes ago, thanks to the participation of the media in this, this country has seen what these students are capable of doing. In the coming decades, our future scientists, engineers, and leaders are going to help tackle some of our most challenging problems. We are going to need you, whether it's improving our health, harnessing clean energy, protecting our security, succeeding in the global economy. We're going to need you. Our future depends on a new generation of young Americans who can help reaffirm our role as the world's engine of scientific discovery and innovation. America is the birthplace of the airplane and the air conditioner and the polio vaccine and the Band-Aid and the light bulb and the internet. Who knows what this country's next young people can bring to us in the next 50 years or even in the next 5 years? One thing's for sure, we never know where science might take us. Big discoveries haven't always had the most obvious starting points as well. For instance, one day Richard Feynman, a leading American scientist after World War II, was sitting in his university's cafeteria, and across the room he saw a guy throwing a plate up into the air, and he noticed how it spun and tilted, and he said to himself, now you know what? I'm going to figure out why that plate wobbles like that. Simple question, right? He knew it might not be all that important, that it was just a silly little problem, but he really didn't care, because he was like Secretary Chu. He was passionate, and he was hungry for the answers, and he was very curious. He was having fun just figuring it out for no reason at all. He was just playing around. And you know what that led to? The process that started when that guy threw a plate up in the air eventually turned into some new ideas about quantum electrodynamics. And Feynman won a Nobel Prize for physics in 1965 for that work. As he wrote, he said, the diagrams and the whole business that I got the Nobel Prize for came from that piddling around with that wobbling plate. So maybe it was just a wobbling plate. Or maybe it's the way the wind blows through the trees, or the way the dust makes you sneeze, or how watermelons explode, or when you drop them from a 2-story window. But to the parents and coaches and teachers here, I urge you to continue to let these students just play. Just play around with these ideas and these possibilities. Let them get their hands dirty. Let them experiment. To the students, I just encourage you, don't be afraid to play and to ask questions. Don't be afraid to step off the beaten path as you learn, to find those new answers. And never, never, I tell my girls this, don't be afraid to fail, because oftentimes in failure comes the best ideas. Have fun. Keep having fun. Keep poking around. And truly always follow your passions, no matter what people say. Our country and our world, we need your energy. We need your creativity. And who knows, maybe you'll save thousands of lives with a new vaccine or finding a new way to grow soybeans. Maybe your life's work will be on display right here at the National Building Museum someday. Maybe you'll learn how to meet our country's energy needs using only the sun's warmth and the earth's wind and water. Maybe you'll change the world in ways none of us can even imagine now. What's always been true is that with enough creativity and thinking and a lot of hard work, science has shown us that time and time again that maybe can be the beginning of something truly wonderful. So thank you all. Thank you for your hard work. Thank you for your passion. And we will be supporting you every step of the way. We're so very proud. Thanks again.
I'll create a diversion for you so you can walk across the front here. Nice round of applause, please, for our First Lady and those wonderful remarks. What great advice to poke around, to get your hands dirty, to keep asking questions. You never know when that next idea will come to you. She mentioned an American-invented air conditioning. We're so grateful to Willis Carrier this morning for making this a very comfortable place to be. You've been a great audience. Now it's time for all of you to be recognized for what you've done for the past couple of days. We have our award ceremony to begin. Yesterday, all the teams participated in the Division Team Challenge Science activity. The #1 ranked team for each division will receive $500 for their school. I would ask for each of you to stand where you are so we can applaud your accomplishment. First, the Arrhenius Award for Chemistry. My soda is flat. The Greater Sioux Falls Homeschool Association from Sioux Falls, Idaho. Would you please stand right back there? Good job, guys. $500 for you. The check is in the mail. Our credit is good, believe us. The Brommery Division in Geophysics, titled When Was the Ice Brought Out? Our winner, Logos School from Moscow, Idaho. Where's the Logos School? In our green shirts here. Congratulations. And this is very topical in the Curie Division in Geology, oil spill cleanup. Maybe you've got some ideas. Glastonbury High School, Glastonbury, Connecticut. There they are. Our next winner, the Darwin Division in Biology, Darwin's Finches Revisited. Our #1 team was Red River High School from Grand Forks, North Dakota. Good job, guys. In the Einstein Division in Physics, the topic was electric circuits. Our winner hails from Pinecrest, Florida, the Miami Palmetto Senior High School team. Good job. Congratulations. In the Fermi Division, General Science Fermi Questions, our winner, they're just going to take home everything, aren't they? The North Carolina School for Math and Science from Durham. In the Galileo Division, Astronomy Spectral Analysis, our winner hails from Scottsdale, Arizona, the Basis Charter High School. Basis. There they are. Good. And lastly, from the Hypatia Division, Mathematics, Minimizing Distance and Cost, #1 school, $500 goes to the Science Academy of South Texas from Mercedes, Texas. There they are. Dr. Chu here. And now we have some very special awards to present to our regional Science Bowl sites that have hosted and coordinated our regional competitions for some cases 20 years. I'd like to invite our Energy Secretary, Dr. Chu, to join us back on stage for a photo opportunity. I'll be calling up the individuals from the laboratories. Would you please come up and have a picture taken with the Secretary? Nice round of applause for our Nobel laureate again. The following laboratories have hosted or coordinated a regional Science Bowl event for all 20 years that this has been in existence, all 20 years. First, from the Ames Laboratory, please welcome Steve Karsjan. Steve. Nice trophy for you. A photo op with the Secretary. Steve, thank you for 20 years of devotion and commitment to Science Bowl. For all 20 years at the Idaho National Laboratory, Steve Zollinger was the man. Steve, come on up. Congratulations to you. I was talking earlier about Googling Sue Ellen Walbridge. Oftentimes when you got Sue Ellen, you also got Linda Lung, because Linda has been the regional coordinator for all 20 years at the National Renewable Energy Laboratory. Linda, congratulations to you. Here she comes. And lastly, we're indebted to Barbara Smoke from Savannah River for 20 years of hosting regional Science Bowl competitions. Barbara, congratulations. Come on up. For the past 10 years, we've also had two very devoted laboratories, the first one being the University of Southern Maine, Dr. Bob Sanford and Dr. Bob Kutch, with the two doctors, Bob, come on out. Congratulations, gentlemen. Lots of energy there, lots of spring in their steps, lots of commitment to Science Bowl. And our last plaque goes to Tony Reed from the Department of Energy's Knowles Atomic Power Laboratory and GE Research and Development Center. Tony Reed. Thank you. Congratulations, Tony. And now for the middle school double elimination team winners. Each the following teams advance from the round-robin double elimination final, and they're going to receive $1,000 for their school science department and a plaque, a notable achievement considering how many schools we started with at the beginning of this competition. Teams 5 through 8, let's welcome to the stage John Witherspoon Middle School from Princeton, New Jersey. John Witherspoon, come on up. And their coach is joining them. There's a huge check somewhere. There it is. All right, if you can hold that for the photographers, thank you. Guys, you should be smiling. This is a good thing. This is a good thing. Let's give them a round of applause. John Witherspoon Middle School. Next, among our top middle school finishers, the R.C. Murphy Junior High from Stony Brook, New York. Here they come from between the curtains. A nice plaque for your school and also a $1,000 check for all your success here at the National Science Bowl. Congratulations to R.C. Murphy Junior High. And these students, again, they probably got a Metro Fare card. They only live about 15 minutes from here. We're very proud of them. The Tacoma Park Middle School from Silver Spring, Maryland. Come on out. And I know you guys were here earlier back in November for the demonstration Science Bowl that Mrs. Obama witnessed. And I saw the pictures, and you did a wonderful job that day against Kenmore Middle School. Congratulations, Tacoma Park. $1,000 for you. And the last of our schools from the double elimination teams from Niskayuna, New York, on the shores of Lake Placid, Van Antwerp Middle School. Van Antwerp, come on out. I remember reading about one of you who likes to take long walks on the beach, and I thought, in New York? Where's the sand? So it's Lake Placid. Nice to have you guys here. Nice smiles there. Congratulations. The middle school model solar car competition. You had to design it, build it, race it, and this car that won, that was the fastest on the 20-meter track, we've got some trophies for you. The top 3 teams in the solar car race. First, in 3rd place, their car went 6.610 seconds. West Lafayette Middle School from West Lafayette, Indiana. Come on out. But of course, a team from Indiana would know something about racing cars. Nice job, all of you. There's a trophy in there somewhere. There it is. There's the trophy. 3rd place in the solar car competition. Second place, 6.577 seconds. Almost won, but not quite. The Roosevelt Middle School from River Forest, Illinois. Roosevelt, come on out. Waiting for their moment in the sun. We're glad to provide it for you. Congratulations, a nice trophy to take back to Illinois with you. And our first place team, and that's another round of applause, please, for our young people from Roosevelt Middle School. Where's your chivalry, guys? You're letting the young lady carry this trophy. The first place team with the fastest car, St. Christopher School from Tonawanda, New York. .217 seconds. They beat everyone in sight. Our ultimate winners in the model solar car competition. Nice to have you here on our dais. Congratulations to you. Great smiles. Thank you. Thank you for all your good work. We have another award for the car engineering design competition. Each team had to document their construction and the testing of their cars. It was an engineering schematic that included specifications for the body and scale drawings. The teams were interviewed by a panel of judges. The competition was fierce, but the best design document was presented by Will James Middle School from Billings, Montana. Will James. I think Will James is just making its way up here now. Will James is home to our accomplished paleontologist, the young man who has 2 species of dinosaurs named for him already. And now, what an entrance. You guys had to play the crowd here. Come on up. Will James Middle School. Nice looking group. Ultimate winners in the car engineering design competition, all the way from Billings, Montana. Congratulations to all of you. Now we go to our high school awards, our double elimination teams. We saw some of the finest here in these last competitions, but behind the scenes also the best of the best. First, from Central Academy High School in Des Moines, Iowa, would you please welcome the team that's going to take $1,000 home to their school science department and a plaque. Central Academy High School, here they are. You're all hitting your marks beautifully up here. You can come back. Congratulations, $1,000 to Central Academy. Another of our standout performers in the high school double elimination competition from Chaska, Minnesota, Chaska High School. Here they come. Congratulations to the team from Minnesota, Chaska High School. Our next winner, they made a long trip, and it certainly was worth it. We enjoyed all of the competition you provided from Goleta, California, Dos Pueblos High School. Dos Pueblos, here they are. $1,000 for their science department and a plaque to take home and an outsized check. Another team of great competitors hails from Marietta, Georgia. Please welcome George Walton High School. Come on, George Walton. Symmetry looks great. Thank you guys for moving. Thank you, George Walton High School, Marietta, Georgia. Our next winner hails from a town that is so essential to American history, Lexington, Massachusetts, the high school there, Lexington High. Come on up, guys. Great team. Great picture, joined by their coach. Congratulations, Lexington. Next, we saw how well North Carolina did in their very first appearance on Science Bowl. Another team making their very first appearance and making it this high in the competition. Please welcome Little Rock Central High School from Little Rock, Arkansas. Lynbrook. All right, let's go to Lynbrook High School from San Jose, California. I think they're waiting in the wings, yes? Good. All the way from San Jose. Thank you, gentlemen. And their proud coach joining them. Congratulations. Thank you for coming up onto stage for us. Their neighboring school, Tacoma Park, won in the middle school division, and now just down the street from Silver Spring, Maryland, please welcome Montgomery Blair High School to the stage. Montgomery Blair. the pride of Montgomery County, Maryland. Nice to have you our team here today. Thank you. Congratulations. Our next team hails from Palo Alto High School in Palo Alto, California. Come on up, Palo Alto. Everyone is beaming, no one more so than their coach. Welcome to the National Science Bowl stage. Congratulations for your good work. Great shot. Thank you. Congratulations, team. Next, a former National Science Bowl champion, always a contender from Fort Collins, Colorado, Poudre High School. Come on up, Poudre. Great tradition out there at Poudre High School as far as Science Bowl is concerned. Nice to have you. Congratulations, team. Next, from Portland, Oregon, please welcome Sunset High School. We've got $1,000 for you, Sunset. Nicely done, all of you. Hope you enjoyed your time here in the nation's capital. We enjoyed having you as part of our competition. Sunset High, congratulations. And the last of our high school teams, they live even closer than Montgomery Blair. They're from right here in the District of Columbia. Phenomenal school, Woodrow Wilson High School. Come on, Wilson. Who? Congratulations, Wilson. Thank you for making the hometown proud. Great job. Thank you. I was about to say we have no money left. I don't know who you people are. Not to worry. The secretary says, yeah, it may bounce a little bit. Secretary, if you could hold that up just a little. This is one of those real long names. This is West Windsor Plainsboro High School South High School. After saying all that, come on up. Get your check. $1,000. Great job. Thank you, West Windsor. Our next awards are the ones that are probably most eagerly anticipated. Everybody wants to be popular. These are basically popularity contests. We call them the Civility Award because they're based on which team out there, which of you were the best sportsmen, showed the most academic involvement, and were just all-round indispensable to the running of this year's National Science Bowl. We have two award winners, middle school and high school. At the middle school level, the winner is going to receive a trophy, and each team member receives a water-powered clock courtesy of IBM. In addition, each team member gets a Kindle and a gift card. Very nice, very nice. This team so said the judges, was extremely respectful to all the officials, coaches, parents, and other competitors. When they lost, they were gracious to the winners. When they won, they always commended the other players on the opposing team and would appreciate the knowledge that came from the other players. They were just good guys and gals. All the team members were involved in a wide variety of academic activities. They do things like the National Academic League, CalcuSolve, Geography Bee, Spelling Bee, President's Bowl, and writing competitions, as well as athletic events. The team has competed with dignity and respect throughout this entire Science Bowl experience, and our winning team, the most popular guys in the room when it comes to middle school, they come from Wexford, Pennsylvania, Marshall Middle School. Marshall. The clock is wonderful. Meeting the secretary is wonderful, but I think everyone envies you your Kindles, so enjoy them. There they are, the Middle School Civility Award winners, Marshall Middle School from Wexford, Pennsylvania. You guys made an impression. And as a Pittsburgher originally, I appreciate the Pittsburgh Nice that you brought here to Washington. Nicely done, all of you. Now for the winner of the High School Civility Award. They get to attend a science research trip that's going to take place in Alaska. This team will also receive a trophy. All of you get that water-powered Clark, courtesy of IBM. You'll get a digital camera from an anonymous Science Bowl volunteer that you can use on your trip to Alaska. The judges said this team was very gracious. They were never pretentious. They were always sincere. They appreciated everything everybody did for them, and they were always thanking the volunteers no matter what they did for them. Even though the team lost a match or two, they were always friendly. They were eager to discuss college selections with other teams. And when they saw a team later in the day, they would always make a point of asking, how did you do in the competition? And they always wished them luck. This team should be commended on their academic involvement, and they will be attending the National Academic Quiz Tournament in Chicago shortly. The winning team, our high school civility winner, hails from Sioux Falls, South Dakota, the Greater Sioux Falls Home School. We'll keep clapping as long as you're walking. They've got the long trip. Come on around, Civility Award winner. Here they come. They know how to milk this moment. The big men and women on campus, the Greater Sioux Falls Home School Civility Award winners. They look really happy, and you should. Thanks for adding so much. This is all about scientific knowledge, but it's also about good manners and good sportsmanship, and you exemplify that to the nth degree. Thank you. Civility Award winner, congratulations. Our final awards for our top finishers in this long competition, our top 4 middle school winning teams. We've already awarded the trophy to Albuquerque Academy, but each of these teams receives a trophy, a plaque, $1,000 for the school's math and science department, in addition to calculators from Texas Instruments. Our 4th place team, their seats are still warm. They're going to have to jump right back up again. our Civility Award winner, Marshall Middle School from Wexford, Pennsylvania. Team number 4. I hope the Pittsburgh Post-Gazette makes a big fuss over you guys for all that you've done here in the nation's capital. Congratulations. $1,000 trophy and plaque for Marshall Middle School. Great shot. Nicely done. Our third place team was last year's middle school national champion, Hopkins Junior High from Fremont, California. Come on up, Hopkins. TI Inspire calculators courtesy of Texas Instruments. You get a computer-based lab data collection system for your school, SmartView from Texas Instruments, and $1,000. That's a lot of booty to take home for what was a wonderful performance here at Science Bowl 2010. Congratulations. Hopkins Junior High. And our second place team, what a splash they made in their first ever appearance on Science Bowl from San Ramon, California. Please welcome Gale Ranch Middle School. Come on up, Gale Ranch. They're receiving 2 of those computer-based lab data collection systems, courtesy of Texas Instruments, plus the $1,000, the trophy, and the plaque. You guys have to promise to come back again next year. Congratulations. Our second place finisher, our runner-up in the middle school competition. And now for our high school winning teams, our last awards this afternoon. Each of these teams receives a trophy and $1,000 for the school's math and science departments. In addition to Texas Instrument calculators, our fourth place team hails from Arcadia, California. A lot of California winners. Arcadia High School. Come on up. Just a super team. Came close to winning it all. Enjoyed having you as part of our competition. Arcadia High School from Arcadia, California. Nicely done. It's an all-California cavalcade here because our third place team comes from North Hollywood, California. North Hollywood. You guys have a big cheering section. I can remember when you took the national championship 2 years in a row. Lots of talent here at North Hollywood High School in Hollywood, California. $1,000 and a computer-based lab for your school and a great trophy. Thank you all. Thank you, gentlemen. And our second place team, I can't say enough about them. The defending champion. Last year they got to take a trip for 2 weeks to Sydney, Australia. They have lived and breathed Science Bowl for so many years. Their 14th year, tying with the most ever appearances here at Science Bowl. Mira Loma High School, Sacramento, California. Phenomenal job as always, and we'll look forward to seeing you back for the 15th year next year. Congratulations to a perennial champ, Mira Loma. Before we dismiss you for lunch, a round of applause because he's been shaking a lot of hands up there. Secretary Chu. Thank you, Secretary, very much. On behalf of everybody at the Department of Energy, I'd just like to thank all of you students and coaches, all the family members for all you did to make this year, our 20th year, probably the best. Special thank you to all the many volunteers out there. And as I do every year, let me ask you, especially this year, since Sue Ellen is retiring, take a moment as you're packing up, as you're sitting on that plane going home, or soon after you get back before all of this starts to fade, and tell Sue Ellen how much this meant to you to come here to the nation's capital for an experience of a lifetime. Please do that. I know it will mean an awful lot to her. I just want to thank you. You've been a wonderful audience. I hope you've had a good time. Lunch is awaiting, and I'm going to turn this over to my friend Lilas, who will tell you which tables and which way to go. Thank you very much.